the Chinese plugin that streams to both platforms. I don't know why there isn't a translated version, but that's just how it is. And then I'm going to go to my VOD channel. Oh, wait, no. YouTube. Oh, bother VOD. Start that up. Click on the thing. Mute the thing. Pop out the window. And now YouTube chat is up on screen. Let's see, that's my broadcast monitor, just in case I need to moderate, and bring that thing over here. You guys are so well behaved that I don't have to do anything. Let me check over here. It says it's on, but it's not working. All sites. View in Chrome Web Store. Oh, look, it's not available because we hate you. We have to be able to serve you advertisements on every web page, rendering them completely impossible to operate in the first place. All right, I'm good. We're good. We're good. Cameras are set up. That camera's actually working again. We're good. We're good. So I got out one of the VFD displays. This one is just like the one that's actually installed in Burn the Subs right now. So I want to get this thing running because the VFD displays are kind of neat. And in Python, we can just have like a very simple structure to call upon the display. It might be it's likely going to be very easy for us to do. We just have to check a couple voltage levels and make sure that we can give this thing enough power to operate. I may have to bring in the variable power supply. This thing, which would have made our lives nice and easy, this breakout board, restart to install the latest Windows updates. News. Yeah, and that's a great time for me to restart and have my computer reconfigure itself and put more advertisements or whatever. This breakout board is cool and all, the cable's a little long, but there's a bit of a problem. Here. Oh, well, there's two problems now. God, what a nasty cable to plug and unplug. It doesn't fit. I can't plug into this with this. I would need one of those weirdo 3M cables that doesn't have the side stuff to plug in. Annoying. I think I gotta find one. How many pins is it? It's a 40 pin. So 3M IDC 40 pin. No, you know what? Narrow header. I don't think they make them that narrow because it needs those side things to hold on. Yeah, see, that needs the side things. And then on the N303, that pin that can plug in, the one that can plug in anywhere, I would only be able to use that if I was 36 pin, because then that could plug in the middle and I wouldn't be able to reach the top two pins and the bottom two pins. That would actually work. They restructured how extensions work to try to break ad blockers. uBlock made a light version that works on their new /restrictive platform. I see. Origin was the key, because they made uBlock was like, I don't know what happened to that. Something stupid made it not work, and then Origin came out alongside of it, and then that was the solution. But now they changed the way everything works. But I guess they made that work, huh? Hold on, I'm just pouring some seltzer water so I have something to wet my whistle. All right. Yeah, so that doesn't, I don't know if that would fit. I need to figure out what 3M cable that was. It's an IDC cable that can plug in without the edge pins, and then I need to drop the 4 edge pins, the 2 up here and the 2 down here, and then that way I would be able to plug into this pretty narrow thing, because these IDC cables need to have clips on the ends of them. What's up, Scampy Me? How about a header riser that makes the header higher? Yeah, that could work too. If I had one that was 40 pins, I could plug that in, and then the IDC cable could plug in on top. Not as elegant, but it's still a good solution. I'm not going to be using this and burn the subs. We can just move the memory card over to like this Raspberry Pi, and then I could use it. Which I guess is a thing. We could do that. I should probably move this up too, so it's shorter. I have all these Raspberry Pis out. Bam, bam, bam. What is that plug? Hold on, let me go get one. There's one over here. I recognize names sometimes. Let's see. M303. Grab the one that's Dave's. The viewer that sent in the M303, I still have all of your information, and I promise, I will one day return to work on these again. They're just, for some reason, both the one that was sent in and Dave's are super quiet, and I don't know why. Why are they so super quiet? We looked at everything. I really did my best. I have most of that board reverse engineered. I don't have it in like a coherent schematic. It's a lot of work that I got to go through. And as much as I love doing that kind of work with you guys, there are times that I just don't know what's going on and I need to do my own personal work on it. And it's just like, I'm not getting paid to do any of that. So it's like, you know, hiring me to do that kind of work is prohibitively costly too. It's just not something that one would do. Like a repair technician would be the best way to go about that, and they would just replace everything, right? And so I'm actually trying to learn how this thing works. There's no money in that. there's only experience with technology in that sort of vein. I should be doing other stuff with this stream. I should be doing more popular things. Anyway, I wanted to find out what this cable was, like what series is, what's it called? Because this is the most evil IDC. I'm gonna go lurk in to say hello. Hello, lurk away. Thank you very much for doing so. Right here, we have the most evilest IDC cable in existence. See, the whole thing about IDC, insulation displacement connector, IDC, is that they've got some security measures to keep you from plugging them in wrong. It's easy to plug them in wrong. They've got the clips on the end, and those keep you from plugging this thing into anything that has more pins than what this has. It's also got this little nublet on top, this little keyway. They're called keyways on connectors. These are sometimes used, these little indents are sometimes used as well. The more keyways you put on a cable, the more someone is going to violate all of your security measures and plug them in completely wrong and blow up their synthesizer. But anyway, so you've got all these features on it, and in the case of this Raspberry Pi case, the designers of the Raspberry Pi put the standoff holes way too close to the IDC cable. I mean, they insisted on, you know, 1 billion GPIO pins, so I guess that's cool, but they didn't leave enough room for an IDC cable to plug into the edge here. Now, I've got plenty of jumper cables. We can still just put this thing on jumper cables, right? If we want to use the cool looking one, but it would have been really cool if they had designed this so that I could plug in the big IDC cable, and if I found where my black IDC cable was, this thing would have looked awesome. What is it? This breakout came with a black IDC cable. It's really cool. I don't know what happened to it. It got lost in the shop. I was like, this is special. Let me put it somewhere safe. And now it's gone. That's what happens to these kinds of things. So what we could do is we could take this IDC header off and move it up, but we still can't plug it in, and I can't shave it down because then it'll just not work. It won't have the clips on the ends that hold it down. IDC is basically the same thing as Vampire Clip. You got these clips that are sticking up that have this narrow channel in the middle, and when the wire gets pressed into it, it will break the insulation and then make contact with the cable on both sides. It's sort of a shortcut to putting a bazillion pins into a cable that goes somewhere. And then you can break these apart and solder stuff to them and make, do all kinds of weird stuff. They were sort of the solution for getting tons and tons of pins to your hard drive in a computer. It turns out that differential signaling is a shitload faster and noise-free, and it doesn't block air. So we've gone to SCSI formats that use differential signals, which is why hard drives now have that really neat little cable that clicks into the back that's super narrow. I prefer SSDs that go directly onto the motherboard. I like that much better. I think that's a better... Google for Raspberry Pi GPIO 40 header CG2. Oh no, I used to use Rainbow Cable and everything. Rainbow Cable goes through the whole Roy G. Biv in order to display what pin is what. When you get to the other end, you can sort it out. I don't need to do that. I don't want to do the Rainbow Cable anymore. That used to be, what is it? The buddy of mine from Philly was like, that was your signature. And I'm like, oh, I don't know. It's just something that engineers do in order to keep all the cables straight. But anyway, point is, 3M decided to, for some reason, subvert all of those measures that make IDC cable good to use. And they made this abomination. This abomination allows you to plug in anywhere. I just plug it right in there. Now my synthesizer is connected to this 40-pin header. So what I could do is find one that's 938, 40, 39, 38, 36 pins, and then it would plug in like this, and I just wouldn't have access to the pins on the end. That would be kind of elegant. What is this header? This CG2 header? IDC. Header. Boom. I mean, I could put a DuPont header on it, yeah. Let me just Google what you told me to Google, and then I'll be able to find it. Polug. Yeah, I mean, you can put spacers on it too. What are they doing there? Is that just to cover it over? Weird. I could put like a right angle adapter on it. I kind of like the keyboard Raspberry Pi. That's kind of neat. I don't know, that keyboard's probably not very high quality. I'm not finding what you're trying to link to me in images. Yeah, something like that to space it upwards, or like this to make it a right angle. That's a weird one though. I'm not spending $2 on that. I could just use a Raspberry Pi that doesn't have a case, and then there's like that one. I don't think this is low profile on the ends though. This would be. This would break it out in such a way that I could actually use it and even probe in and put like a thing on the pins there. But I don't need to do any of this. This is all just window dressing. None of this is necessary. We'll just use the other Raspberry Pi that I have. We won't have the cool looking one. One day this thing will get used. Maybe I'll make this my what do you call it? Pi hole. That would probably be a good use for it. Or if I could find this header, then I could maybe make the breakout work. Would have been an elegant setup, but we're going to use the busted looking one. And I'm not using the Pi 5 because I don't need all that power. That's too much power. Too much responsibility. I haven't found any use for the Pi 5 yet. Let's shorten this thing so that we can at least use the breakout nicely and have it sit just right here. We'll just make a really short IDC. I'll give it a little bit of space, but not much. Just enough to like work with it. I have a couple of these header IDC thingies. So we're gonna make note, pin 1 is the red stripe. That's the usual way to do it. And we wanna crimp it from, with the cable exiting the nub side so that it plugs in cleanly with pin 1 on pin 1 of the Raspberry Pi, which is this upper left-hand pin. And then I've got to take these headers off and replace it with screws so that this thing can plug in. Because with these headers there, it can't plug in. Life is grand. All right, yeah, and we'll keep it on these short stack headers, and I can just plug it in right there. And this one's loaded up with all the Raspberry Pi heatsinks that we need. So in order to manipulate IDC pins, this is sort of bonus content. Bonus content for the stream. But bother, why is start soon up if you haven't started the stream yet? Well, we're not working on, it's sort of, I mean, well, we are working, I don't know, shut up. Shut up. You shut. Willow has already had a banner day today. She's been barking at literally every molecule in the universe. So I think she's going to be quiet for the rest of the stream. Oh, there you did it. You pissed off start soon. Would you consider doing a hardware review for a Eurorack module? I'm doing a Kickstarter starting next week. If you think that's something that would benefit you in any way, I would be willing to take a look at a piece of hardware, sure. Would I have to send it back? Because what if I really like it? You're talking to somebody who doesn't even have a working Eurorack at the Mo. Starting next week, huh? And my policy extends for just about everything is that consider that you are throwing it away by sending it here. My policies are none. I don't have any policies regarding hardware being sent to me, but if you feel that's something that would benefit, it would be I would totally be interested in free stuff. So IDC headers are kind of a pain in the butt. What I'm doing here is I'm working this very inflexible plastic, and there's a little nubert on the end of this thing, right? A little nubbin. And so what I do is I get the tweezer, the thin tweezer in there, and I pry down, which is going to push this little bridge upwards, right? And so you're trying to push that little bridge upwards without completely ruining it, because you'll want the next one to come in to actually be able to contact. So you could either pull with the tweezers in, or give it a little incentive, sort of soften some of the plastic, and then push on this, and it'll unlink. You got to be really careful though, because you can pop this plastic and then this thing doesn't hold together anymore. Now this is just responsible for strain relief on the cable, because if you have the cable like this, it's a little bit more strainy when it bends right up against it. It's not necessary to have this bar there, but that helps with strain relief by having the cable double back on itself and get linked down. I have some modules from a demo batch left. We'll see what I can do. How can I contact you? Below there is my business email that I have neglected to check for quite some time, and I will check it again. Probably tonight I'll log in and check it, because not a lot changes on the business email, but it's workverbdesign at Gmail. So that's my work email, and that's the best way to contact me. Or you can drop me a line on Discord. That's probably the best way. Actually, that's probably the best way, is to just drop me a line on Discord. My PMs are open, and we can work out, you know, if you're serious about sending me it, I'm all for that, and then I can, you know, give you where you want to send it to. Demo modules. It sounds fascinating. I would be fascinated to review a Eurorack module. Figure out what I have to say about it. I'm gonna guess that I'm gonna be overwhelmingly positive about it, but I'll try to levy some realistic criticisms. I'm not a Eurorack guy. I don't really know modules and Eurorack and stuff. I've been learning it from my end, and my end is the engineering side. Now you got to be really careful with this one. This one will break. It's an outside nub, and so you can get to it from below, and I just kind of coax it. I coax it into snafu. I kind of work it up above the little blocker here. until I can push on it myself. I don't pull it from behind, I push on it with the end of the tweezers. And the microscope really helps to visualize this. You don't necessarily need a microscope to do it. I'm just being really super careful because these IDC cables are ready and willing to explode at the drop of a hat. You got to be really careful with them. And so now we are faced with all of the vampire clips, what make an IDC cable work. So this is how they do it. They have 2 offset vampire clips. So it goes doot, 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 back and forth. And that makes up the clips that fit into here. Very cheap to make. They just stamp out the, what is it, gold coated parts. And they're very easy to put together. So we have now reset our vampire cable, our IDC cable, and it is ready to go. So let's go to the view over here. We're going to make it a whole lot shorter. And for that, I use a flat vise. We're probably going to have to like pinch and pinch and pinch in order to get it to seat. So, nubs out. We're going to make this significantly shorter. We'll go like an inch or 2 away. And then pin 1, the pin with the arrow on it, needs to line up with pin 1. So we'll just choose an arbitrary area here and then get the top of it and start clamping it down. So this can flip either way. All this does, it's just a guide and it's symmetrical. So we can flip this either way. It doesn't have a pin 1, but these little troughs help guide where the IDC cable is going to land, and it makes sure that our IDC cable is properly aligned, assuming that we are straight up and down on this thing. So I'm just going to hand fit that and move that over to here. And let's see, that's still going to, oh no, I'm on the wrong side of the cable. So we got to remember that this flips over top. An engineering would be perspective would be nice. That sounds, yeah, I mean, that's exactly everything that I can bring to the table. Is I know a little bit about synthesizer design now, as somebody who's worked with systems in these things. So so hopefully that adds something to what. Hopefully that's what you're looking for. Sorry, I'm doing 2 things at once. So I could cut the cable here, but I'm going to keep it for now. And then I need to press this with the vise so that the vampire clips go in. There's like 250,000 of them. So I need to make sure that I can put enough pressure on it to actually get it to clamp in. It turns out I am going to have to cut it right now. This is not really when you should cut it, but whatever. I'll do it here just because I can't fit the cable on the vise. If this was like a bench side vise, like one of the ones on the end of the bench, this would probably fit and I could just use that to do it, but I'm just going to clear this up so I have room to work. And I'm not sure how aligned I am. That's pretty good. These are like older technology, and so you can kind of like play it by ear. So I'm going to start cutting that with the flesh cutters. I don't know how, I can't get to the whole thing. Maybe I should just use the scissors. No. I should be able to get to this. Just got to fold it a little bit. That bend in the cable is very annoying. But yeah, depending on what I get, there's no doubt in my mind that I think it's the coolest thing in the world because I got it for free. And then I'll try to route some people over to your Kickstarter. From the time of master slave. See, I appreciate not using that problematic terminology. Instead, we use dom and sub. And sub always does what the dom requires. It's just better for the kids, you know? Better for the kids. Think of the children. See, what I'm doing here is I'm just running around and just clamping. Instead of master slave, I like to use dom and sub. Yeah. Just, think of the children. Miso and Mossy, I didn't know, was just an attempt to demystify master and slave by calling it master in, slave out, master out, slave in. It's like SparkFun doing TXO and RXI. All right, that is compressed. It probably could use a little bit of... No, that looks good. So just to double check the work. I don't actually think that that's problematic, but I'm happy to change the terminology. I know people have advocated for that for a long time, and I'm perfectly willing to call it something else, just because, yeah, if you don't want to have slavery terminology in your electronics, fine, you know, great, let's change it. But I don't really care all that much, but I'm willing to go along with it. So that is perfectly seated. That should, by all means, I'm looking at these little nublins and making sure that everybody's centered in it, and I'm making sure that there's no big gap in front of it. And it looks like everything is in order, although it may need a little bit of extra squishing here and there, but I have a feeling that this I2C cable works perfectly fine still. Double check. Ooh, that would be annoying. Okay, yeah. Pin 1 is with the red stripe, so it is indeed properly configured. And then right now, it looks like, oh no, bother, you put it on the wrong side. Well, here's the deal. This flips over like that, and you try to get the nice tight bend in there. Nice tight bend, and then you come in with the top bar, and you're good. And you can orient this the other way around. You can have it on the opposite side of the cable and have it go the other way. This was just how it was oriented before, and it gets it to the Raspberry Pi with the Raspberry Pi face up. So that's all we're going for here. I want the Raspberry Pi to be nearby, and if I need to grab it, I can grab it and move it around and manipulate it. I could have made this shorter. Shorter would have been perfectly fine. I don't know if short lurker would have been okay with it, but shorter cable is totally fine. And it would have been a little bit less desk space as well, like that, if it was just straight over. I'm rethinking if I want to do it straight over. Do I want to shorten it even more? This is going to the derelict cable bin, which is just a big box that sits below my feet. Honestly, I do want it to be shorter like that. I think it's cleaner, and the Raspberry Pi just sits right there. It's not like I need to route this anywhere. I want to make it shorter. So going to the cable that we've already manipulated, because it's easier to re-manipulate, I'm going to pop out all the stuff, and I'll show you it this time up close. Ooh, I made a noise when I hit the screen. So this has already been bent up, right? So there's a little bit of give, and we've worn away at the plastic that's supposed to hold the thing in. Now it'll hold in perfectly fine after we've manipulated it, but this just, yeah. Yeah, let me get the music out of here since I've already started. We're not programming yet, but we are pro gaming. Let's just get that out of here, and you guys can see the effect of starting the stream before I have a 45-minute intro. So what I want to get running today, we have cracked the code, so to speak. We've done Hello World. We have an entire LED that flashes when we say, hey, run this program, right? We've got our whole setup with WinSCP, making it so that I can literally get into the Raspberry Pi, double click on it, and it will show up. Now, if we move the memory card, that's going to change the MAC address, so my IP address isn't going to be static anymore. So we got to figure that out. We're going to have to make Raspberry Pi 124 in order to test this thing, because the case that I wanted to use, the really slick one, this giant heatsink case that looks super awesome and futuristic, the one that I saw, I think at Micro Center. No, I saw on Amazon, and I said, ooh, who dat? What's that case doing? Look at this. Looks awesome. But can't use it. I would have to put a header standoff here or a right angle adapter in order to have this massive IDC cable go to the breakout thing. It would have been nice. I could have had this cool looking futuristic Raspberry Pi setup. Oh well. So Test Pi 2.123, we're going to retire. Give me your badge and gun. And we are going to put Test Pi 124 into, wait, there's already a disk in this one. What were you? What were you? I don't, huh? This might have been a, hopefully this isn't a dead burn the subs one. We'll just sneak you in here. Who the hell knows what you are? I don't even know what I am anymore. So we're gonna put this one in here. and I'll have to do a little jockeying with the network in order to get this one up and running. But this can be our test Pi. It's already got standoffs on it so that it sits at a reasonable height from the board. I'm going to replace these two with screws, and then I'm going to make this IDC cable super short. It's going to be about this long so that these two can just sit with each other on the breadboard. And I think that'll be a much cleaner test Pi setup. Yes, sure indeed. So we'll make it like this long. It's really going to be, I mean, I would love for them to be right against each other, but I do kind of want to have a tiny bit of flexibility. I mean, this is like a massive IDC cable. It's like a total pain to work with. But when doing these, there's a certain way that you can get into the IDC cable and shorten it or manipulate it. So what I do is with the tab that holds down the IDC cable, if it's looping back around, you can press from here the tab through. It helps if you have something like a thin pair of tweezers that are flat and wide so that you can get into the space between the pin and the plastic bar that holds it in. And we did this already. We did this during the intro, but it's basically you put the tweezers, this is three things, right? It's a bar that holds down the cable, the thing that holds the individual strands in position so that the vampire clips can displace the insulation, IDC, insulation displacement cable. So that's this one down here, this hoop down here. This is very easy to break, and this clip right here holds it on. Now, I have worked with broken ones before. They're totally fine. They work just great. But it's this, there's a nub here and then a bar here, and both of those break very easily. So what I do is I get part of the tweezers into this space right here, and I just kind of manipulate it a little bit like this, right? Manipulate it a little bit like this, and that's going to soften the edge at the top of this nub, and it's going to blow out this bridge just a little bit. But these things can, you know, when you deal with an IDC cable, they can be old and they can be very brittle. So what I want to do is I'm getting my fingernail right there, and I'm going to press up on the nub. Now, we did this already, so it's going to be easier to do this time. And then you want to absolutely be sure that you are removing this in parallel, because otherwise it's a giant moment arm that will move like that and break this part off very quickly. So there's that part manipulated, right? Paying attention to the fact that this is on the other side of the cable now, we will put that all the way up here, probably around here, so that we can do the loop around. So now I need to take this part off. So what I'm going to do is get the tweezer in the end, and we'll put that on the microscope. That's not the microscope. How's everybody doing? I'm pretty sure I've got all of my streaming stuff going on right now. Yeah, we're streaming to a total of 5 people. I hope they benefit from the absolutely amazing stuff that I'm doing today. So I'm going to get in here and try to move this up and over without busting it. It looks like, I mean, there's probably a key that you could put into these two that'll help you bend up this piece, but getting just in right here is really where we want to be. So, and maybe I could just push on it. No, that doesn't look like it'll push. Yeah, so we'll just try to get under here. Hands are a little shaky today. And they're dirty. What is this stuff? Ugh. You know, working on a microscope, I should probably use one of those finger brushes every day. So there, see? I only wanted to get the width of my tweezers in here. And remember, these are very thin. So just a little bit of a thing in there, of a friend in me, and you tilt it up so that you start pushing it outwards. I don't want to push it very far right now. I'll just get it just above that little area there where it's a little bit loose. I don't want to move it. I got to be really careful because I can break off the other end by over moving it. On smaller cables, this is more of a thing because it'll be a higher angle. So over here, I can't press down. I got to hold it in my hands. So over here, I'm going to do the same thing. Just try to get the tweezers into that area. You can sometimes twist them a little bit. And now if I just kind of move a little bit back and forth, I can get it up and over and push it out. And you can see I'm going slowly. I'm going slowly and I'm being very, very careful about what I'm doing. I have broken more IDC connectors than I can possibly communicate to you guys. These things break so easily. I didn't know IDC existed. I was wondering how you were going to solder all those cables. Yeah, so they just displace the insulation. And we just did this one, but you can see here that it just got all of them. We got all of them displaced. I probably could have pressed it down a little bit further than I did. But all that does is just these spikes. It just drives it into spikes that then make electrical connection to the wire. This is something that I learned a long time ago. And then when I started streaming about like, what, 2 years into streaming, they told me that it was called IDC cable. And I'm like, wait a minute. I called them flat cables for a very long time. I mean, I just put it away, but on the modular synthesizer power things, those are all IDC cables. But yeah, they're very easy to alter and work with. It's a good technology. It just blocks airflow, and it's a little bit inefficient if you don't have like flat space to put stuff in. So I'm gonna actually put this here, and you can see I'm putting it on the opposite side because remember, this has to flip around. So as long as pin 1 is on the side with the red cable, I could put it here. I could put it here if I really wanted to, and that would still contact pin 1 because of the back and forth nature of this cable. I had a steak sandwich with very, very thin cut steak and just some random bag of cheese and a harissa, mayo, and ketchup sauce. They put all three, a little dollop of all three in a bowl and just mix it, right? The harissa was a little bit too sweet. I wanted it to be spicy. It was on a hot dog bun. I don't know if that 27 carbohydrate brioche hot dog bun is going to bite me in the butt in terms of streaming. I really should just fast into the stream. I should just fast into the stream. I shouldn't eat. I don't eat breakfast, so I do eat lunch, and I've been overdoing it with lunch. I mean, I'm a big fat guy, right? I've started on meds that quell my overall perception of hunger, so that has helped. And I could probably fast all the way through stream, and I probably should because then I don't burp. I took a famotidine ahead of stream, so with any luck, I'll be able to continue to be animated and use my voice to its fullest and not go oh every now and then. I really hope so. I've been poking in on some people's streams. Do you break fast? Oh, I start crying. Yeah, I start crying almost immediately. It could be like a meeting with a manager and I'm in tears like right away. If I don't get enough ketchup packets, I'm just eyeliners running, everything. It's a mess. I need me a girl that will tell the cashier that I didn't get enough pickles. Okay, so IDC cables, this wonderful piece of technology, because of the back and forth nature, this cable then that cable, that means that as long as the red stripe is on the side of the arrow, our pin 1 is always going to be pin 1, no matter how we orient this. And because of this piece, the part that puts the pressure in there, we have all of these little divots that are going to guide the individual strands of cable into their respective vampire clip. These displace the insulation and then connect to the strands of wire inside, the juicy insides, the marrow of the wire. So yeah, these are cool. These are easy to manipulate. The first time you try opening one of these cables up, definitely find like an old cable that you don't care about because you will break them. The plastic does get a little brittle over time, and the manipulation of the two sides of it are enough to break this. What you're seeing is the result of many, many years of experience manipulating these fucking things. Because old computers used to use these for the hard drives, and I used to shorten them so that there was a direct, just one line of IDC going between them. And then for a little bit, what we would do is peel the individual strands and bunch them up to make a round cable that air could get around. I used to do that. I am an ancient human being. I have been around longer than Encino Man. How do I want this to go together? This needs to be with the nub facing this way because I want the nub to face out because pin 1 is over here. So when we plug that in and this loops back around, it'll plug into this one. And it's going to be short, but not too long. It's short enough. And so this is very important. This is our guide. This is going to guide all of these strands to make sure that they go in properly. Obviously, a little bit of manipulation on your end is also required, but what I need to do is just put this and figure out what the length is with it flipped around. That's pretty good. I like that length. Do I actually like that length, or am I going to regret making them this far apart? That's enough that if I need to put it upright, I can put it upright. But it's still a little bit far. Molex Molex crimping does suck. Although, you know, with a big crimp tool, I saw actually in one of my best builds, one of my favorite builds, the Molex cables were IDC cables. So I was able to break them apart and shorten them and just put them all back together, and it worked. It was amazing. I had a straight run of Molex going down all the hard drives. It was amazing. Absolutely my favorite Molex style. But the regular Molex, the Molex cable in general, I don't know, like Satan worked with 3M back in the day, or Molten Corporation, I don't know, Molex Corporation. I think it was the same people that designed, oh, this is crooked, wait a minute. The same people that designed that 3M IDC cable that can plug in anywhere, that can just plug in anywhere on the thing. I think the same people designed the Molex cable in general, and it was their pièce de résistance. This was their crowning work. They had divine countenance when they put this thing together. They could see every single pixel. They could see code. They weren't even looking at people anymore. It was just ones and zeros when they created this thing, because they created the most evilest cable ever to exist on this unforgiving green earth. Everything about the Molex cable is designed to hurt you. It just hurts you. It's all blocky. It doesn't like to unplug. It has like 2 plug cycles. They poured all of their malice and hatred into this one cable. Hate Molex. I hate them. The new drive cables are just so much nicer. Actually, I'm thinking of the modern power plug that has sort of an IDC style. I'm not even thinking of Molex. I'm thinking of the more modern stuff, the things that we decided to do because Molex had ruined everyone. And they said never again, and so they designed the newer scheme of power cables for computers. All right, so I'm using the vise to crush this. It's not incredibly even, but I did a lot of passes, and I made sure to kind of walk it down very carefully. We're just going to inspect this as much as we can. It's flat. The ends are closed. It looks as though we have made contact. We could, if we really were masochistic, put pins in all of these and test them all. I am willing to trust this because all of those are centered on their thing. So I think we've made good for my super duper chode cable. And all I need to do is tightly double it back. So it helps you just press with your thumbs in order to put it 90 degrees there, and then press with your thumbs again to put it 90 degrees there so that it wraps very tightly indeed. And then the bar goes on, this super fragile bar that will break at the first hint of any kind of conflict. This goes into the center hole. You just push it in evenly. And now we have, through manipulation, created the chode cable, the ultimate in IDC technology. Look at this little guy. Yeah, this one is not as tightly bent as it could be. There we go. We just got that little tiny area right there. So this is going to be our Raspberry Pi I/O adapter, and it will allow us to use this breakout. And this breakout is made for perforated prototyping boards, and now we can keep the Pi nice and close. We just have to plug in this. I'm gonna get screws. Oh, or nuts. Actually, that might interfere, so it's possible that I need to get new standoffs. Now, the panhead laptop screws are the ones that are my favorite in order to work with stuff like this because they are small and they are M2.5. I believe this is M2.5. M2.5 is about the right size for these Raspberry Pi mounting holes. So let me grab an M2.5 kit of screws. There it is. Actually, I wonder if these would fit even better. Oh no, you know what? I don't think they work here. I have these the Taro drones, the company TAROT. They like using these shoulder bolts, and these are some of my favorite bolts to use in things. They don't fit in a lot of different products, but what they have is this beautiful little shoulder there, so you can have a large hole and have this clean looking hex bolt fit through. And I guess what they did is that they would use it on their carbon fiber, but I don't think these work here. No, they don't. They stick up with the shoulder. Okay. Very hard to find uses for these. So the pan-headed laptop screws are what's going to go in. I always like to try my special hardware on stuff just to see. And then we need different standoffs. I need standoffs that don't have a pin. So that's the standoff bin. I like buying kits of hardware so that you've got all these sort of weird little extra parts just in case you need something to work out. Problem is then you have all of the weird hardware left over, and the parts that you use the most are the ones that deplete like very quickly. I'm at a point where I am considering throwing out some JST headers just because I've got too many of them. I never use them. All right, M2.5, I believe that's this one. Make sure I get two of the same length. And that's all. I'm gonna leave the back standoffs, so we don't need to worry about those. And just make sure that it fits through the hole. All right, that's good. And so these are pan-headed laptop screws, and they sit clean and they sit flush and they look good. Look at that, beautiful. They're especially nice in 3D printing because you can print a little cut in for your screws. And if you get the sizing right, even if you don't get the sizing right, if you give it a lot of wiggle room, it still looks really good because you have concentric round things that are flush. It's kind of amazing. I would suggest looking into them if you want something to look good. Because they use them on laptops where you have the exact same thing so that everything is flush on your lipper tip. I mean, I guess I could put 4 of them in. Yeah, let's put 4 of them in. Let's just do that. Get 2 more of these. Yoink. Yoink. And then 2 more of these. Yoink. I guess if I feel like putting it on a substrate, I could do that, but we're not going to go that far. We need to do the wiring of the screen and look up how to hook up what do you call it? Noritake e-tron character LCD. It's going to be, the pinout is the same as your typical LCD screen. It's just not in one big line. It's 2 rows of connectors. And then we can see there's most likely a Python library for that sort of screen. So we can just get that into the project very quickly. And that's sort of, I'm setting my goals small. It's Friday. I don't want to think. You don't want to think. We're just going to kind of step through this in the most dumbest way and get it rolling. So we got a couple, I know all of the tasks that I need to perform. I know everything that needs to happen. As far as the MIDI thing goes, that modular synthesizer MIDI thing, that is coming in the mail. I've got 2 different orders of parts. One of them is from an electronics company that I didn't know whether or not I could trust, because apparently the potentiometer that they used in that synthesizer module for the MIDI module that Erica Synths used is made out of pure unobtainium. It is an absolutely unsourceable part. I was not able to find it at DigiKey. I was not able to find it at Mouser. DigiKey does not use Alps potentiometers. Alps, obviously I could buy 1,000 of them from Alps. That would have been totally fine, but that potentiometer was unfindable until I found this Tadya Electronics, which is an electronics sourcing company that likes kits. And I guess maybe they stocked up on this thing because it's part of a kit. And so I am their demographic, as opposed to like $4 a potentiometer. It was like $1.35 from this place. So I ordered a couple of them. I paid about $20 for the entire order. And I'm going to get, I think, maybe four potentiometers out of the whole thing. you know, I always order extra just in case. So I don't know when that's going to get there. They say it's going to be something like 4 days, which is incredible, but I think it's probably going to go through customs before it gets here. And we'll just see if I can trust this company. All right, so now pin 1 at pin 1, pin 40 at pin 40, but we've got the arrow in there. I'm just going to double check just because. Yeah, there's pin 1. There's an arrow on the actual IDC cable that indicates where that pin is. No, it's not AliExpress. It's a Tadya Electronics. It's a Korean company. These standoffs could be a little bit larger. Okay, let's go with slightly taller standoffs. The board is just a little bit floaty. It is floating. Or is it just that one? Is that one shorter than the other? I think that might be it. Yeah, it wasn't AliExpress, although you can find clones of that potentiometer on Ali. The one that I'm getting is from Alps, the nice Alps thing. And apparently, and this is Short Lurker, CyanoCat did a lot of, NanoCat on Twitch, did a lot of research to find the rip-off ones, and some of the, yeah, this one's shorter than the others. And I found the Tadya Electronics, but Short Lurker found a thread on Mod Wigglers that was discussing what value, wait a minute, this one is smaller too. I got two that were the wrong height. What is my problem? There was a Mod Wigglers thread where people were talking about this MIDI kit, and apparently it's supposed to be a 100 kilo ohm potentiometer, but in the schematics, it's a 10 kilo ohm potentiometer. But Erica Synths dropped in and said, oh, go with the bill of materials. So I guess we saved our bacon there a little bit by doing a bit of legwork. I didn't want to do any legwork on this thing and just kind of suffer through and make it to the best of my abilities. But it turns out it's using enough eclectic hardware that I had to do a little bit of reading before putting the whole thing together. But now we'll be able to build it perfectly. It'll go together smooth. This is, these should be like just the right height. No bench needed. No stool needed. I think it's NBN. That's not a reference I should probably make on stream. All right, tweezers, where do they go? So I need to find a standoff that is just the same height as those other two. How about you? Doesn't seem like it needs to be much higher. Oh, because it's sitting uneven. Let me try a size up from these. Maybe that's the ticket. Because this wants to be a particular height, and I don't think... No, these are actually too long. Okay, so we'll go with the match to that. I'll just go with this. Double check the height. Too short. I'm starting to build a case for using the short ones. I don't know why the heights are so close to one another. It's like I must have sanded some of them down. This one is just the right height. Weird. Because like I think what's happening is the front is... No, it does need to be a little taller, because see how this pushes down? Actually, I think they are just the right height for one another. It's just the cable's inflexibility is what's making it go all over the place. And then these are, in fact, different sizes, but just barely. Just barely. What I should be doing is getting like an old piece of scrap carbon fiber or something like that, and putting all this stuff down on that one piece so that I have this slab that I can use to do Raspberry Pi stuff. What's up, Gonad? We're just doing a little bit of test hardware making. I could also 3D print something, but you shouldn't 3D print out of all your problems. I'm sad because I can't use my Super Space case, unfortunately. This will stay at the same IP address, but I'm moving the memory card over to a less featured Pi that at least has just the bare minimum of heat sinks on it, so that I can use our beautiful breakout. And I shortened the IDC cable, We had a whole IDC cable shortening lesson, and now I've got pretty much a bench setup. This isn't really sitting flat because of the inflexibility of the cable. This is at a slightly higher location than that. But if I did put something underneath it all, I could probably just staple it all down and have my little test bench, put the screen on there too. That would be really cute. Let's not go too far. Okay. So now I need to power this thing up, and we need to see where the IP address is and make it 124, and I'll print out a label for it and put that on there. So what I'll do is I will simply plug it in, plug the plug, and I can't show you guys this, but I'm going to open up my router page, 2.1, and then I'm going to view the list and see where the Raspberry Pi is. That's Octopi. That's actually legit. Bulb 1, desktop, unless... Is that powered on right now? Let me check over there. No, Octopi is always powered on. That's right. All right, hold on. Let's go back and let's look at the list again. There's 17 clients. Red light's on, green light's flashing. When old mother cries. Shenzhen Fanten Tech. Shenzhen Fanten Tech. What the hell is that? I wonder what that is. Exhaust fan is on a weird one. Raspberry Pi is on 2.201. I think that's our target here. So I'm going to go into the DHCP pool, and the stream's going to hiccup, which might kill YouTube. I'm not sure if that killed YouTube chat or not last time. Let me just double check and make sure it's 2.201. 2.201. Okay, so we're going to change that to 124. So I'm going to go to my LAN settings that you guys are not allowed to see. Go to my DHCP server and click on the list, on the pull down list, and find Raspberry Pi, and then 2.124. And add that, and then click save, click apply. Okay, so that works. That's my full name, unfortunately. Okay, that appeared to have worked. Everybody came back online. There may still be some growing pains. Let's see if the growing pains were actually just needing to fart. Okay, that works too, even though it didn't go into chat. That didn't even show up in chat. Oh my god, why is it doing this? Wait, it keeps farting. Oh, because the chat needs to be cached, I guess. So let's cache chat. And let's double check. There's my test message. And then if I set off a fart. Oh, what? Hello? Enter. Enter. Send. Send a message. Connecting to chat. What's going on? Wait a minute. Okay, that showed up too. Check that window. That window's working. Check YouTube again. Well, I'm sure YouTube works just fine. And then let's check the landing page for YouTube VOD. I don't know what happens when I reset the router here. It looks like I am still indeed streaming. 1, 2, 3. My hand doesn't do the American 3. I can't. I'm not that flexible. Ah! Yeah, it doesn't work. Okay, cool. So we're back online. All right, so we had a little bit of a hiccup there in order to get all of my stuff working. Hopefully the lights still work. Let's just try a shop toggle. Let's set up lights toggle. Yeah, so those are, oh yeah, the shop lights don't go with that. But yeah, those all work. Let's turn them back on. We can see again. And our Raspberry Pi should now be 124. So I need to go into WinSCP. WinSCP. Come on, buddy. New tab. And then we're going to edit. And this is 124. But now when I log into it, it's going to bark at me that the authentication stuff has changed. I just click accept, 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 accept. And here we are with our 123pi.py, and that is just the manipulation of the sleep command and the LED. Okay, so we're back in business. More IDC cable goes into the bin. And now we've got this wonderful breakout for all of our pins. Oh, and like I said before, the heat dissipation on the Raspberry Pi, very even. It's beautiful. So you can see, the untrained eye may not know what they are looking at. The thermal imager, which is this window right here, shows you relative heat. And I say relative heat because it's constantly evaluating what the range of color is that it's to display. If you see a thermal imager with this color scheme, with the purples being the purple and the pink being the lower temperature and the yellow and the orange being the higher temperature, that is actually copyrighted by Lepton. Lepton is a thermal imaging company. They make all kinds of neat little doodads that are very, very expensive indeed. The more yellow something is, the more relatively hot it is compared to all of the other temperatures that this thing is seeing. So right now, my hand is yellow and orange, and this thing looks a little bit cooler. So you can see the emissive heat, the emissive long-wave infrared heat for my hand being approximately 98 degrees Fahrenheit, 98.6-ish degrees Fahrenheit. It's probably a little lower than that because we're looking at emissive heat, not internal heat. That's sort of where this is scaling to because I represent the higher temperature in the view. So this is a little bit lower than body temperature, but it is still generating a bit of heat. The thing about that is I've got these heat sinks here. They don't look like they are hot, but they are indeed hotter than everything else probably here. It's just that the metal reflects thermal energy. So the metal here is not hot enough to emit enough long wave on its own to not look shiny. You can see the reflection of even my pin tool, maybe my middle finger reflection in that metal. This is a little bit more matte. Sometimes you can get a reflection off of matte surfaces, but you can kind of see how the image of that heatsink changes as I move my hand over it, and it reflects the heat that I'm emitting. Yeah, if you want to see the relative sort of an idea of how hot the heatsink is, you can put a little painter's tape on it, and that will heat up and not reflect the long-wave infrared. Although we see the reflection of heat on the USB ports, and they're shiny. Yeah, it's crazy. And they're not even, these aren't even polished. These are dirty as hell. So what we're looking at is something that we can actually view on long-wave infrared and get a good impression of how much thermal energy it is actually emitting, and that would be the circuit board substrate. And so if you look at the circuit board substrate here, you can see there's a little bit of a concentration of heat around the power supply, but otherwise, all of those temperatures are relatively even. It doesn't look like any one thing is concentrating all of the heat. And that's because the Raspberry Pi org put a lot of work into making sure that there is a robust and useful ground plane in order for them to dump all of the heat of the processor onto. I do. It's the giant block of aluminum is one of the better displays. Where is that? Oh, it's right here. You can have something like a giant block of aluminum, and as long as it's cool enough, it's looking a little bit more rough. I wonder if it's oxidized a little more. I think if I get closer to the camera, it does better. Here, let me get in here and sit down and angle the camera properly. But yeah, the block of aluminum can be a mirror to long-wave infrared. You can see this image of my face, which is reflected off of this not really shiny, not really clean block of aluminum. It reflects it perfectly and gives you enough information to have a face. I had a buddy who had one of those Airstream trailers, and the thing was, it looked like it was made out of mirrors. It was amazing. On thermal imagery, the Airstream trailers, they look like they are spaceships. So anyway, the point is, through the thermals, we can see that this thing is generating a lot of heat, but there's no you can see it's dissipating to every corner of the board. So they did a really good job with the heat dissipation in the Raspberry Pis. All right, so we are ready to do physical computing. I mean, we haven't executed our program, but we got the LED flashing. We should probably test the LEDs on this new setup. Now that we've got the hardware kind of reconfigured, we should give it a go on this. So what I'll do is I'll put the LEDs here. And then we're going to hook 3 volts to one power rail and then ground to the other one. So I guess what I can do is just on this side, I can use a couple breadboard jumpers to make this a little bit cleaner. Oh my God, this is a really busted. Hold on, let me find a slightly better breadboarding kit. This is all the derelict wires that I pulled out of other breadboards. That'll do. I need one of the yellow ones. I've got one project that's currently on the solderless breadboard, so that's eaten up a lot of my breadboarding parts. Okay, that's out of stuff. Let's find another one. These kits of cut wires are not expensive, so it helps to buy many of them, buy multiples, and just kind of tear through them. This one doesn't have any either. Oh my God. Because I think this won't skip all the way to the... Can we get further out? Can we get further out from this? Yeah, we can. Okay. I think I can go a little further. I can go just a little below that. This isn't going to focus. No, that's... Yeah, this is as far as... There. It's a little less claustrophobic like this. Yeah, buy 10 kits and just kind of tear through them. How's it going, Silly Russell? And Gonad. I think I said hi to Gonad when he came in. I don't know. I don't remember. I have no memory. I don't even know what I just said. I was in teaching mode. Yeah, these two are just completely spent. I've got a couple more sitting somewhere, but let's get a little scrappy and just kind of reuse some of these. Let's get a little scrappy. I should probably dump all of the excess ones into one bin. It's just the particular size that I need just is gone. It's gone. Okay, where am I going to get jumpers? I've got a whole bunch of them sitting above here from something that I just tore apart and didn't feel like organizing. The wire offcuts around here, they go down here. They go into this bin right here, the kick bin. This thing has all of the wire offcuts. It's just the breadboarding offcuts. They don't have a particular home, and they probably need a home. It's a shopping bag full of little bits of wire. It's therefore very heavy. I gotta clean up around here. That's stuff that I gotta do tomorrow. Oh, I see. All the little offcuts from doing D-connectors. Oh my God. So that's all that. What was that? Solid stranded wire? No, that was a stranded wire. What was that just flew by? Oh, it was a little fluff. These are all over the place right now. Oh, you can't even see it. There's a little fluff there that just flew by. Those are all over. I've been cleaning dog hair. Okay, so here's a yellow one. That'll help me jump to the power rail. It's all solid. Oh my God. Oh, yeah, we can grab this ground right here. So ground, the reason I'm using these is just instead of having a big wire come up and around, this will be nice and clean, and it'll allow us to kind of work around all this stuff and not get completely frustrated at all the stuff in the way. And positive 3 volts, well, here, put a bend in that. These go straight up and down. In computers nowadays, the orange wire, I believe, is the designator for 3 volts. We need a longer than that. I can't color code because the different colors of wires are the the different lengths of wires. So it doesn't really work out. Get out of here, hair. It's always like a derelict hair ruining my day. All right, so positive and negative are hooked up for better or for worse. And then over here, I can access 5 volts. The thing is, the 5 volts from the Raspberry Pi, I don't know if it's going to have enough current for the Noritake e-tron display. I think this is a problem we ran into before, but maybe we'll just try our luck and see if we pump 5 volts into this sucker, if it won't overdo it. I'm not sure. And I'll do ground over here too. Oh, that's going to block that hole, so I might as well do this ground. They're all connected to the same thing. We saw how unified the grounds are on the Raspberry Pi. Yeah, 300 milliamps. Gonad has worked with similar VFDs. I prefer these VFDs because they look a lot less cheap than the LCD character displays. I like them. They're a bit more fancy, and they lend sort of a credibility to your stupid project. your dumb project that's barely even held together. You go, ooh, look at that VFD. That looks nice. What happened to the white wire? Wait, what? Oh, I used it. Yeah, okay. What happened to the orange wire? That was the one I was looking for. Maybe that one I can just put a little bend in. But they do require a lot of current. So 300 milliamps through the power supply as well as the Raspberry Pi, that might tank the whole system. I'm going to put 5 volts over here. The displays, as far as we... Oh, Jesus Christ. Display, as far as we know, the last time we checked, it will work with 3 volt signals. And I don't think the display is saying anything back to the Raspberry Pi. We will look it up, though. I'll look it up and figure out what pins need to go where and assign a pinout, because this is eventually going to become the pin scheme for Burn the Subs. We'll have the LCD on a particular set of pins, the TX and RX for the sending of G-code or whatever will be on another set of particular pins, etc., etc. Although, actually, wait, we don't TX and RX the G-code in this case. We send it to Klipper or Gerbil, which will be running on the Pi. Gerbil would be running on the thing, and we'd need a TX and RX. Klipper would be running on the Raspberry Pi itself. That would be an API call, which will be cleaner, hardware-wise. This mother... Come on. Go in there. I swear. Curse words. Let's see. Where's my pin tool? There it is. No, that's not the pin tool. What happened to my pin tool? This one will do. These horrible dental tools that I have. Open! I don't think that worked. Yeah, this one's refusing to operate. Gauge tool to the rescue. This thing has so many uses. This one is just being an absolute nightmare. All right, fine. Go to a different one then. It's too long. What about you? There. That was so much less painful. Something's wrong with the clip in this one. Those OLEDs are really nice, but so tiny. Yeah, they're tough. The one that I used in the synthesizer, it's like I've got all this information on it, but I need like a magnifying glass in front of it. They look really cool though, because each pixel is lighting up on its own. So you can put it behind like a piece of plastic and it'll look cool. All right, so now we know what all of our pinouts are. We technically have code on here that will use what is it, GPIO 17. Why is it over here? GPIO 17 to flash an LED. So now it is as simple as me hooking up ground to the LED. So we go over here, and let me actually move this around this way. So the use, like, where do you use the different types of jumpers? Well, okay, so over here we have the LED thing that I made, right? And so I'm gonna hook this up to ground. So I'm gonna use a flat jumper to go to ground over here. Finding the length is gonna be difficult because I've got sort of the dregs of my wiring stuff, but we don't need a lot of wires to make this happen. So ground over here can just go to this thing. If I wanted to ground all of these LEDs, I could probably actually just do this. Wait, we could do this and just do that. There, I made it to do that. So now that all of the LEDs are hooked up to ground, so they're positively lit up. Now to actually go from that to the LED, since we are going to be wiring and rewiring stuff, I might as well just use a yumper. And so the yumper that I want to use is just one of the short male-to-male ones that's not going to kind of get in the way of everything, which is not that big. Oh, there's the good one. Oh no, never mind. That one's terrible. I could use a solid wire to go over there, but it's going to kind of get in the way of everything. And if it's just a temporary thing, it actually really helps to just use a short male-to-male jumper wire. If I could find one. That's kind of long. That's really long. I have short ones. I don't know where they are. I think I've used them all in too many different things. They're scattered to the wind. This is another thing of wires that I should probably buy again. That's that kind. I'll put that with that kind because we're going to need them. There. That's what I was looking for. Something that's just a moderate length that'll allow me to go from my LED to G17. And so that's not going to get in the way of stuff. I've seen people make, because I mean, you buy a kit, right? When you're just starting out and you don't have the variety of stuff that I do. So you would use all this kind of wire to do all of these kinds of connections. That's fine. It just makes it so that there's a big bird's nest of wires sitting over your breadboard. And if you go up to the breadboard and go like this, not even pushing down, you just kind of pat it a little bit, you can completely destroy a circuit or make it, you know, have all kinds of noise that is detrimental to the function of the rest of your system. So I like to have all of my stuff locked down, right? Like have it on its own board, have very few connections that can be manipulated like that, even if that's going way out of my way, which oftentimes it is. And I'm doing all of this effort for naught, you know, for very little functionally advantageous modifications. But you know what? A clean test setup is a happy test setup, and having your thoughts together and all of your complicated wiring things laid out in a nice, neat fashion will help you troubleshoot. I have been to the ends of the earth and back troubleshooting things, and avoiding the hassle of a messy setup is, in my book, worth the time. Okay, so I had some in a box that I need to find a use for. They had an excellent small handheld stuff. Use for, what are we talking about? Oh, the OLED displays. Yeah. The insulin pump folks use those when you have like a signal relay between your phone and your insulin pump, or your glucose meter and your insulin pump. They make these little battery powered devices that the diabetics carry around that do that sort of middleman RF stuff. And it has its own little OLED display, which tells you how much battery life there is, just all kinds of cool stuff like that. Okay, so we need to go into WinSCP. We need to, we're already logged into the Raspberry Pi. I managed to not kill power during that whole thing. So we need to click on the PuTTY session. And then I need to go to, is it dir? Yeah, it is dir. So cd test pi, and then we do Python 3 and 123.py. So when I run 123.py, all of the sudden, out of the blue, our LED starts blinking. Hey, how about that? Now I use the orange LED again. I could use whichever one I want. So now we know that our system works and everybody is happy. You see that? Look at that. Look. that's going through a 1K resistor to a blue LED, and it's enough to blast out our retina. Now, Mark 1 eyeballs looking directly at this thing. It is a bright blue LED. This would be really good at illuminating something that you'd really want to view. But you can see that the yellow LED is actually not much dimmer. I think the green LED is pathetic. So the green LED needs a little bit more current in order for it to look proper. And so you would want to manipulate that 1K LED to be something like, 600, 800 ohms. And then this will brighten up a little bit more. And that could be down to my soldering. But one of the big steps when you're creating a device that people use is to sit down in a dim room and look at the brightness of all the LEDs and alter the value of your current limiting resistors so that they all look about the same. You could also do that with PWM, but still. I put the small display on my Zigbee hotspots. Just an extra display for temperature at that room. Yeah, that's a neat thing to do with them. So our code works. Let's Control-C to stop our code. Now we know that we've got all of that hooked up properly. The next step is to look at our screen. Yep, there it is. It's a screen. Well, now. Now, we have to actually look at what the screen is. So this is a Noritake-itron. Noritake-tron. 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 Noritake. Itron. I don't know how to say any of that properly. Anyway, Noritake. I'm gonna say it. I'm gonna say it with the worst American accent that I possibly can, and you guys will just have to deal with it. Finding information on these screens can be a little bit difficult, but this company still has a website. I love them. I love them. I wish they would sponsor my show because they make these vacuum fluorescent displays. Vacuum fluorescent displays, most people are familiar with them from like stereo equipment. They're just these beautiful light green style displays that shine through stuff. So you can have a tinted window on this and the letters will shine through and look really, really crisp. I love vacuum fluorescent displays. They are sort of like a weird alchemy that makes your project, it bumps up your project a little bit just by virtue of having this really interesting look to it. So the OLED displays are kind of the same deal, where if you've got the glowy pixels sort of shining through, they look really nice. So this display has a model number. We need to look it up. So this is CU225 ECPB W1J. I cleaned up the shop and I kind of cleaned out all the dog hair from the fan, and I must have kicked up a bunch of allergens because my eyes are itching now. All right, so CU225. I think I've downloaded the datasheet previously. It's probably in a folder in here. Let me just see if I've already got it. So in Stream Project. Let's see, solenoid, levitate, keyboard, ESP notes, channel point fart node, Merc wheel 303, Twitch graphics. The Merc wheel needs to get a display, and I think I want to make a display adapter that uses the car communication schema, that one wire communication scheme, and then I can put a bunch of like very rudimentary, like basically I can send it certain data packets and it'll display stuff on the screen in front of the steering wheel. I'm going to need to do more 3D modeling in order to manipulate that properly, though. Thumbnails, Twitch graphics, solenoids, module tester, no. Mixed panel, no. Mill mods, no. Okay, so I don't have that there. Maybe it's in my downloads folder. We did that long ago enough that it could actually be in a project directory. Doing a quick sweep. What would it be called? CU200? 24063? No, that's not right. Okay, so let's just look for it online. The website itself, they have to email you in order for you to download. So we're not going to use the website itself to find anything about the screen. Let's close this down. We don't need this. We don't need that. I've got too many tabs open right now. We don't need the pinout anymore. We actually have all of the pinout stuff that we need on this breakout board. We don't need that tutorial. We don't need the flashing an LED. Project M Visualizer, going to keep that up. Need to keep this up. Need to keep that up. Keep that up. This can go. This one can go. One thing that I would like to do is resurrect the tourbillon mechanism, but not have it use, hey, there's a sub. Why is it so small? Zenmeister Siggy. Hey, thank you so much for the 2 months. I appreciate that very much, the 2-month sub. You've decided very recently to stick around, and I appreciate that. Okay, we do not need this, and we don't need this. Okay, there. A little bit of memory goes a long way. Noritake Itron CU 200? CU 225 ECPB. You can buy it for a measly $94. I get these off of eBay. I found a bunch of them on eBay a while ago before prices went insane for everything ever. So, oh, I should have gone with the DigiKey datasheet. W1J. W1J. We got them, ladies and gentlemen. All right, so let's take a look at what the datasheet has to say. Life cycle, obsolete. Well, yeah, but they're timeless. They're timeless. It's a character display. Oh, did it take us to the website? Great. Great. Okay, they do actually have the datasheet. Oh, wait. LCD replacement modules. No. I need this old datasheet. Click here to request a demo. Code library available. VFD CUU. $225 UX1J is a high brightness module. Interesting. Yeah, these are meant to go in instead of LCDs and just look nice. Pretty cool. Brightness control feature. Serial interface or 4 to 8-bit parallel interface. And then there's potential for a brightness boost. Compact model. Code library. Where's my data sheet? Ah, here we go. 225, oh boy, it was, okay, 225 ECPB. 245, 225 UX, UW. Is that all we get? Yeah. That's a different display. Ugh, makes you download the whole thing. 20 by 2 line, LCD compatible, etc. Pins on the side. Okay, I guess that's close enough. The problem is, I think these are weird and special. I think these are like serial only in some way. I wouldn't suggest you go out and buy specifically this one. Yeah, they take you to the website. Damn it. You got to sift through the whole website in order to figure out what the damn thing is. Yeah, I guess it's going to be close enough, but there's a couple of U225s. 20 by 2. Simplified, yes. That one has a 3D model. All right, so I guess it's just this. All right, so logic input voltage, minimum is 2.0. VCC minus VSS, the typical is VCC plus 0.8, but it will recognize 2.0 volts. So we can tell it, we can speak to it in 3v3. The, hey, what's up, Miato? I mentioned you earlier for helping me with research on those knobs. I went with Tadya Electronics, and they were a couple dollars each. We'll see if if and when I get them in the mail. But I appreciate all that research from the other night, from last night actually. Noritake e-tron screen. the Raspberry Pi speaks 3v3, right? And so if anything is interfacing with the Raspberry Pi, if this thing is to be sending back any sort of data to the Raspberry Pi, we need to make sure that it doesn't blow it up, because these pins are only 3-volt compatible. We can hurt our Raspberry Pi if we send it 5 volts. We should be operating completely in 3 volts, but the screen is old enough that it is in fact 5 volts, powered by 5 volts. It needs a lot of power to run anyway. So the question is, if I can get, USB should be able to handle the 5 volts. You can do, what, 2 amps on USB 2.0? And so we should be able to, well, how many amps does the Raspberry Pi use? They're each probably like 300 millivolts, right? Millivolts, milliamps. What is do they have current consumption in here? $200. So, 100 milliamp overhead is why I want to think about it that way. And then I think the only way that we're able to communicate it with it is parallel interface. It doesn't do the serial 8-bit or 4-bit parallel. So synchronous serial is out. I believe that we are parallel. Although, you know what? Hold on. There's a jumper on it, I believe, that changes that. Oh, but this isn't a comprehensive enough data sheet. We did a lot of research into these things, at least with the other display, the one that has 4 lines on it. Or sorry, the one that does dots instead of characters. Did a lot of research into it, and I found a lot of weird information. There's a lot of jumpers on this thing that can reconfigure it to be different things, but I think we were limited in how we were setting it up. I mean, what's going on here? These jumpers here, setting it up in a particular way. And I can't get information without actually contacting Noritake. Yeah, I know. They've got a good email system where they do get back to you and you do actually get the data sheet. That's why I want to look on the file server, because I think I may have that on the file server. Wear jumper. No. You solder the jumper. You don't wear them. Project. Stream. Noritake. Datasheet. CU 200. CU 2004. 4x20. VFD. Hold on, what's my motivation again? So we do actually have, I did save them last time. Cold and rain, wear jumper. 2025 ECPB. 2004. GUI 140. 240.25. Yeah, none of these are the right thing. Yeah, these are for the 5x7 character display. I don't remember the last time we were working with these. That's kind of similar, but not really. G140, IEEE, IV datasheet. Let's just try searching here for Noritake. Noritake. Oh, come on, you can do better than that. There we go. I'm just seeing if it's in some kind of like a subdirectory. I've already emailed them. I could do it again. I just don't want to do email right now. Looking for, the data sheet on this thing. I want to see how it's configured. And I've used these before, but part of this is that this is going to inform the way Burn the Subs gets wired up too. But, okay, so I don't have anything in here for that specific display. So we can just kind of make an assumption on how it's working. But I would like to figure out what the jumper configuration is, if I could find something at all similar. 4x20, built-in fonts, character size, pitch, and weight. We've got electrical characteristics and operating temperatures and stuff. Command compatible with HD44780. So if we're looking for a library for Python, we might use the HD44870 LCD. So Python using an HD44870 LCD. Hello, friends. Can anyone tell me a tutorial on the HD blah, blah, blah? I found this one. Oh, that's a nice little edit. Sites.google. Oh, okay, that seems all right. Sites.google seems a little sus to me. Using an inexpensive HD 448070 based LCD displays. Okay, so this is for an inexpensive one. We need to find one for an inexpensive one because these are apparently worth $90. Probably much less than that on eBay. Plus, don't look up the specific model number. Look up like the series for Noritake because they have more modern ones and they have ones that can take like a serial interface, which will be much more simple. This thing is kind of locked into parallel mode. We're gonna have to utilize it like that. But in your travels, you don't necessarily need to deal with that kind of nonsense. I think at one point I had a flat cable for this. How many pins is this? 2, 4, 6, 8, 10, 12, 14. 14 pin. I don't think the synthesizer stuff was what? That's not 14. Actually, I ran across an IDC cable that was less pins. Oh, not this one. Nope. That's too many. Too many. Not even close. I need to find a 14 pin IDC, huh? Put that there. Looking through the bin of cables. A magical bin filled with all kinds of weird shit. To see if I can elegantly plug in my... No, that's not going to do it. That's the same one that I just looked at. And then let me just check the synthesizer ones are... How many pins? Blah. That is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. No, that's too many pins. Okay, that's not going to work. Actually, I think this is the synthesizer size. So I don't have any flat cables that would specifically work for this LCD display. It would have been nice and clean, but we'll just have a ton of wires sticking out of the back of it. Yeah, cut to width IDC. That would be interesting. They always rely on the outer, the very ends of the cable to hold the whole thing together, though. So it doesn't really work in terms of like how that would go together. Let me just double check on my IDC cables, see if I can't make one. These are too wide. Yeah, it's relatively compact. If I just happen to have like a weird size with the rest of my cable storage, that would be neat. That's not enough pins. So the synthesizer power plugs are just not enough pins. Yeah, they're all gonna be too weird. I'd have to buy something in order to make that work. It's a shame though, because that would make our test setup even more elegant if I could have just a little breakout that comes over to here. Not necessary, just cool. Yeah, okay. All right, nope. I simply don't have the hardware. Welcome to my sifting through parts stream. Oh wait, hold on, I got another IDC dump. Look at all these different types of connectors. Yes. This is the one, a DB37 is what I used on the 3D printer so that I could unhook the printer with one big cable. Gonad, are you still there? You should do what I did and put all of your 3D printer cables into a DB37. You've already got the chops for all the DB soldering. You could just have everything go into the DB cable, and then if you need to move the controller from the printer, it's just one big unplug. I did that for my own convenience. All right, what are these over here? These are too big. These look like big boys. Look at all these old connectors. That's way too many pins. Yeah, none of this is going to fit. I thought I might get lucky. Is there any other size in that bin? Nope, just huge. All of them get larger. That's not what I need. Ah. Yeah, you dumb streamer. You could have held on to something once. Everybody would have been happy. I gotta find out where my parts for the joystick mods are. We should come back to those, because I can do some 3D scanning in order to figure out... Well, actually, somewhere I've got an inventor, an AutoCAD inventor file that has a 2D drawing of exactly the size of the plate that I would need to put the different controls on the Warthog joystick. On the left-hand Warthog joystick, I could have the knob that goes up and down in order to have that 6th axis. And then I could put in the new plate with all the new holes in it. I originally, when we were building Burn the Subs, I used the blue laser to try to cut out the wrong kind of plastic, and it filled the shop with horrible smells. I'm gonna get super cancer one day. It's just gonna happen. I'm gonna get super ultra cancer, and that's that. But anyway, I was able to make what is it? A really cool cutout panel that was the right size. Nowadays, I could 3D print it in about 10 minutes if I could find my files. All right, so let's figure out what the pinout is here and how we are going to hook up our stuff. I'm gonna blow the text up on this one so I can actually see it. I've accumulated a pile of displays. Well, congratulations. Since I was writing this, design a small circuit board to allow the display to be plugged directly into the Pi. The design files are on Osh Park. I don't need that. There's plenty of code for driving the displays from Python. However, the latest Raspberry Pi includes the HD44780 kernel module. So I decided to use it. Here's how. Cool. All right, this is exactly what we need. I already have pre-asthma. Who else? Yeah. It was a bad day. It was a bad day for owning a nose. But yeah, it definitely filled the shop with some horrible smoke. Add the following 2 lines to bootconfig.txt. They need to be one right after the other. DT overlay, LCD pin D4. Okay, so LCD pin D4, pin D5, pin D6. So HD 44870 pin out. Say dot matrix liquid crystal display. Wait a minute. Can display up to can display up to 1 8-character line or 2 8-character lines. Okay. Wait, 8 character. That seems a little bit. Oh my God. Our profession might not be the healthiest, should become a nature landscape photographer. Well, then you get skin cancer from being outside. We're going to get weird cancer from being inside. Here we go. Here's what I'm looking for. So yeah, D4, 5, 6, and 7, etc. We don't need to know the PA over here. I just wanted to see the LCD pinout. So the LCD pinout, ground 5 volt contrast, RW, and enable. So that pinout's not really giving me all the information. Just do like a character. I do actually, somewhere around here, I have adapters that adapt this over to I2C. They basically just put a microcontroller between the two. This doesn't tell me what the LCD pins are. Jeez. Some of these people making these displays, man. Let your geek shine. No, do not hide your geek. Hide the geek away. Listen, I come from an era where it was not cool to be a nerd, all right? We got our asses kicked constantly. Backlight, power, and ground we don't need because our characters light themselves up. So this is the pinout that we need to adhere to in order to hook up one of these types of displays. I need to actually see what pin is what. This LCD display is supposed to be compatible with this type of thing, but we need one of the ones that has it on the end, which is a weird place. The pinout is actually given to us in the data sheet. I just wanted to verify, yeah, this is all I needed to see. Ground, contrast, etc., etc. So let's just go back to the data sheet for the Noritake Atron screen. Okay, so I guess we'll hook it up like the tutorial said, and I'll get all those together. So we don't need this anymore. I shouldn't have looked that up. I should have just looked on the data sheet. Dumb. I just had to remind myself of what this type of display has. And then I'm going to pull this into another window so that I have both of these open at the same time, so I can take a look at this and actually wire it up. This 816 character is why you see every single HD 44780 type screen have a bunch of chips on the back. The controller chips support the chaining. Yeah, it's there is an I2C compatible Noritake screen. This is not it. And the ones that I got off of eBay were probably put on eBay because they just don't have that function. And I don't think I can activate it with the Yumpers. I don't think I can activate it with, you know, JP1, JP3, JP. I would need to get the more extensive data sheet, and that requires me to email them, and I just don't want to email them right now. Maybe I will in the future, but I don't think this one can be made into an I2C. But I can use the pin out here. So pin 1 is the one on the left there. 1, 2, yeah, 2, there's pin 2 label. Okay, so pin 1. Pin 1 is ground. So let's, well, first of all, I need to find a bunch of these wires. How many am I going to need to hook up? It seems like I'm going to need all of them. Wait, hold on, let's see. What does the code use? Where did that tutorial go? Oh, it's right here. So width 8. This is more than 8, isn't it? Yeah, it's way more. This is 20 by 2. Wait, let me see. This is wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20. 21? I miscounted. I'm super good at counting. Did I mention that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16, 17, 18, yeah, it's 20. It's 20 by 2. 20 by 2, it's in the part number. Jeez. All right, 20 by 2, I don't know what we would need to, I mean, I guess we could just say width 20, height 2. Does that mean we need more of the pin D0 through whatever? DT overlay 4470 LCD pin underscore D4. See, I would rather do this within the Python code than actually have it install into the setup controls is 8 by, even though there's 16 by 1, they're set up and controlled. Okay, so you've got a weird thing you're talking about here. Echo NE dev LCD. This is different. This is a different way to hook it up. This is hooking it up within just the Raspberry Pi. Huh. I would rather it exist within the Python program, but I guess I could do it this way. Let's just see if there's a way to do the HD 44870 from Python. So do that. Python Raspa Pi. AI, I would prefer if you would shut the hell up. All right. RPLCD. Python 3 Raspberry Pi character LCD library for the Hitachi HD 44780 controller. It supports both GPIO parallel mode as well as boards with an I2C port. This might be the way to go. I mean, I know it's already installed in the Raspberry Pi, but I mean, we can just mess around with it like this. Inspired by somebody else's library. For GPIO mode, no external dependencies except rpi.gpio library, which comes pre-installed on Raspbian, are needed. This seems old because we've got, I mean, the library we were using in our code is GPIO 0. I'm wondering if there's already something like this set up in Python. Test script, there's also unit tests, pip install u requirements dev, run the test, GPIO guidelines. I don't know, I feel like there's something built in already to Python 3. Let's try like latest. Wait, what was that question? Help others shop by writing a review. Have you made an online purchase from DigiKey before? Tools, time. Let's do like a year in the past year. 1652 character. I have an HD 448070 driven 5-volt 16x2 LCD that I thought at first I would need logic level shifters, but then I use a simple voltage divider. You might not even need to do that, depending on if something is talking back at the Raspberry Pi. You need a voltage divide if it's talking back. Logic from Pico works fine to drive TTL voltage high, but the other direction needs a voltage divider. Logic level shifter, I wired up an RGB backlit 16x2 LCD using the Pico V-Bus power. Assume it's fine to steal a little V-Bus from the 5-volt. Yes, it is. I put voltage dividers on each of the lines, and like I said, probably not needed. Cool, that looks great. You did a great job. All right, so what's going on? HD driver for the 16x2. Include Pico. So, damn it, that's a Pico library. Son of a bitch. And then we're doing microcontroller coding. Well, very nice job, but over I2C. Damn it. Oh, and they're using a nice looking display. Decided as 16x2 LCD, cheap 16x2, AliExpress. Script to fetch, currently playing song. Okay, but what are you, how you did this? Okay, all right. Boy, it's tough out there. And this says that it was relatively recent, the code. Pipe, counter, date time, import board, import digital IO, import Adafruit character LCD. Okay, we're not using the Adafruit character LCD. Yeah, maybe we need to go back to that guy's tutorial. I'm trying to find out what like the latest is, so that we don't use something that's like super duper obsolete, because you always find out late in the game that you're using some kind of an obsolete library or code base, and that like, oh, this version of Python 3 actually has like a built-in HD 44780. One can even get OLED HD 44780 screens now. Yeah, those look good. Can you get them? Are the pixels large enough though? Because those I2C or whatever, those LCD displays, OLED displays, are so tiny they're hard to see. That's with MicroPython. MicroPython. That's on Raspbian. Python, HD44870 test.py. Sudo nano, so that's adjusting it. Volume IO, I don't need any of that stuff. I just want to see how you're doing this. I don't understand the formatting of this page. Okay, so data 4, pin 25, 18. Register select pin 7. This is startup mode, display configuration type, register select, etc. So is this like console logs? Sudo docker run network host. Pied Piper service. What the hell am I looking at on this web page? Raspberry Pi LCD display, 16:2. Volume IO install. These are just like logs of running a script. Oh, it's in German. Pin out. This might be exactly what I'm looking for, though. RPi GPIO is GPIO. And then they do LCD, all that stuff. And then define LCD, send bytes, bits mode. GPIO, LCDR5 mode, GPIO.low. So that's setting up. That's LCD send byte, displaying it. Message. If name is mdin. This might work. This block of code might work. It's just RPi GPIO as GPIO. So we're not doing the 0 GPIO. They're very similar pixel pitch to standard LCD ones, but they top out at like 16:2. I don't think you can get ones with a lot of lines of text. Oh, that's unfortunate. I mean, like getting the size of the LCD display with Unleash Your Inner German. I don't know. Why didn't that show up in this window? What the heck, man? Sorry, it's my my chat display is being weird. Yeah, it just didn't say it on the other one. The weird. Yeah, I know this is. I mean, yeah, it's all in German. But the wiring is what I can emulate. And it's, you know, I think all the information is here. I'm familiar enough with an LCD, whatever it is, an LCD tutorial, because I've done this a bunch. So just having things like the pinout and the pinout wiring and the code, that's enough for me to go on. I don't need every single word to be translated. Oh my God, this website is becoming increasingly more hostile as I remain on it. All of the ads are starting to kind of leak in. So I'm going to take this code and just cut and paste it into my code, my 123 code, and we'll see if we can get it to run a display. I don't know if I need to do anything additionally. That's kind of why I read the code one time. I don't know if I need to. I think maybe it's importing time so that we can see. Oh, I didn't get a line. Give me that. Oh, even the pop-ups are in. No, get out of here. Oh my God. We're in a very hostile, riddled web page. Copy that. Did I open the image in a new tab? Oh, sweet, blissful, ad-free browsing. Oh, he's using an older Raspberry Pi. They are using a older Raspberry Pi. That's a nice old one. I guess I'll use similar pins, though. Okay, so you can just wget the whole source file, instructions above code. That's all right. I'm just gonna cut and paste it. I'm more familiar with this. The code base is scaring me. LCD message. So what are we sending to our... Okay, display initialization. Main. Initialize all of the pins. Display init. So we're initializing again the LCD itself. Send byte LCD line 1. LCD line 1. Address there is just... I think there are special commands that are in the data sheet that I may have to work in at a later date. But since this is compatible with the HD blah blah blah, I guess we'll continue to... Why is Twitch chat not updating? What's going on? I'm gonna hit refresh on this page. Maybe that'll fix all my stuff. Because people are talking, the AutoCAD is talking, it's just I don't know, maybe I hit a memory load or something. Yeah, it's not coming up there. What's the deal? Hey, computer, what are you doing? Is it like downloading an update right now? Something ain't right. Yeah. YouTube is not receiving enough video to maintain smooth streaming. As such, what? No. That was one time. It's smooth now. All right, I'm going to try to cache the chat again and see if it'll come up. So that window goes blank a little bit. And then I'm going to do another 345. There it is. Okay, now we're back. Although 345 didn't show up on this one, but every time I hit reload, it just like loads again. Everything comes up, and then it's just like, it just doesn't have anything to say. Look at this. So down here, it just stops. Not to be confused with LCD massage. Yeah, that's when you do weird stuff to the front man of the LCD sound system. Who got back together, I think? I think they're doing shows again. Well, the LCD message is 8.0. I don't know what's going on with that. I think that's building up the packet. I don't know if this is going to output something specific. They imported time, so maybe it's going to display some kind of a time, or maybe I need to feed it something in order for it to actually display anything. Oh no, it's going to say Dicestien Kleiner test. Okay, I'm fine with that. That's fine. Let's just do that. Okay, so that's our LCD test. Let's get it wired up, and then we'll put this code. I'll hit Control S, and the code will go into the Raspberry Pi, and we can just run it. Hot Rod MCO. Wow, finally caught you. I keep missing your show. Oh, hey, thanks. Some of the shows have been a little bit too short lately, but, you know, I got to take care of the dog. So they've been a little bit short, confined to only 3.5 to 4 hours of me working on complicated projects. This looks like a decent tutorial, and they're not using any like special crazy plugin. It's just Raspberry Pi GPIO, and then they're putting together, I guess, the responses themselves. Using a library might clean this up a little bit. I would like to find a library that is good, but I don't want to bring you guys along for that. So we're just going to use this person's LCD test, and it'll be in German because it's funny. So let's wire it up the way they wired it up. And by the looks of it, they used a very old Raspberry Pi Model B instead of our 3B Plus. But pinouts is pinouts. We've got pin numbers on this thing, so maybe we can utilize that. So it's 5 volts connected, ground connected. Let's get that connected on our end. Our 5 volts and ground, this one we don't want. 5 volts and ground with the Noritake data sheet, and they tell us that ground and VCC are pins 1 and 2. So let's put that together. Oh, and I need a bunch of wires that are about the same length. I think we've tested the LCDs with these wires before. These ones that are bundled together. So maybe this will be our good opportunity. So yellow for power. And that'll be on pin 2. And pin 1 is labeled. So pin 2 is here. pin 1, black wire for ground, like that. So now over here, we can go to our yellow and black wires, and we can hook them up to the rail that has 5 volts on it over here. So yellow for 5 volts there, this one for ground. Okay, we are rolling. Okay, so what's next? Oh my God. Okay, goodbye tutorial. The web page has become so incredibly toxic when left alone that it is now buzzing us out of anything. And there's no, okay, I just click off of it to, jeez. What a website. All right, oh, this isn't very helpful. This is not very helpful. This is helpful though. VSS VDD V0. I don't think we're doing that. RS and RW. Read write modulus. And were these 5-volt compatible? See, I don't want RW being potentially, it's either RS or RW. I forget which one it is. One of them communicates back. And then, of course, the backlighting anode and cathode we don't have to worry about. VSS VDD contrast pin we don't need. So then we have RSRWE. Let's just look up an LCD pinout. Hold on. I guess I can look through that to the code itself to see what they have. This isn't helping me with a pinout. Register select pin that controls where the LCD's memory you're writing data to. A read-write pin that selects reading mode or writing mode. An enable pin that enables writing to the register. 8 data pins. Ah. I forget what we followed last time in order to hook stuff up like this. I've not done it with a Raspberry Pi yet. Like translate page. Contrast tension. Backlight anode, backlight cathode, and then data. And they're using they're not using D0, 1, 2, and 3. So 4, 5, 6, and 7. We can at least hook up the data lines and then we'll figure out what the rest of this stuff is. So 4, 5, 6, and 7. 4, 11, 12, 13, and 14. This is last 4 pins. And I've only got 4 other pins here, huh? Okay. I'm gonna have to look up some of the other hookups. What happened to that adapter? I have one somewhere, but I don't know where it is. Yeah, the LCD to I2C expander, those things are great. Because then you can have 3-volt I2C going to it. You don't have to worry about 5-volt versus 3-volt compatibility. So DB7 is on pin 7. These are both the same shade of gray. Okay, okay. I'll just have to pull on it to figure out which one. Okay, DB7. Where is they hooking up? Data line 7, 6, 5, and 4. Okay, so 7, 6, 5, and 4. 6, 5. Wait a minute. Whoa, what's going on? There's like a weird lag in the camera. Wait, where am I dropping packets? Am I dropping packets? Oh no, everything went away because I moused over the wrong thing. Let's see. OBS says drop frames 233. which is very few. I think that was while the router was resetting. Yeah, the double stack connector makes it even more annoying. I don't know if they sell. Hold on, let's do a little bit of sidebar research here. Because I used an adapter, an I2C adapter with the beer tap handle display. I don't know. Let's just see if I guess I'll do Amazon. I2C breakout LCD board. That's not right. Memory IC, no. So LCD I2C converter or module. Oh, is that what these are? Okay. These do the one with the backlight because they have that extra stuff in there, but I guess you could probably make it not do that. And then I would need something with the double stack instead of that side by side, which I don't think is going to be something that I can find. Yeah, that's not going to be something that I can find. It would be nice because I2C is so much easier. It's just 4 pins. 2-piece I2C display module. That looks nice. Yeah, some of them inherently speak I2C, some of them don't. I don't know. All right, so that's not really going to work out. I mean, you know, I could always tape the board to the back of the display, just like tape it over here, and then I can have just wires going over to here. But that's okay. Plus, it would have to be like 5-volt I2C. Anyway, this pin here, this very last pin, pin 14, goes to D7, but I don't have D7. (24, 23, 22, 27, 17, and 18). Wait, so they're not... Hold on a minute. Hold on a minute. D4, pin 12, GPIO 18. Okay, so GPIO 24, 23, 22, and 18. So GPIO 24 is what we're looking for. Okay, that's much easier. So this pin here goes to 24. G24. There's 6. G24. All right, get that in there. This will be very frustrating when everything breaks away. So the one above it is the other gray cable, which goes to GPIO 23. Okay, all right, seeing a pattern. And then the next one goes to 22, which is... Oh, wait a sec, which is it? Yeah, it's a larger one. That one is the green wire, or this other purpley gray? Nope, it's the green wire. So this 24, 23, 22 over here. And then the last one goes to 18. So those are all the data lines. But we still have RW and stuff to hook up. And I need to kind of reconcile where those pins are. This is a lot like what it was like to hook up the other Noritake display. Very confusing and a whole lot of lines and a whole lot of cross-referencing this and that and the other thing. Why did that... The chat froze again. What is going on? My computer's doing something in the background, I think, that is killing all of my chat updates. Hard to find. Where... It is what it is was commented on before esports are for losers and pseudo maze and all that other stuff. So I'm going to cache the chat again in OBS. I don't know what's going on, guys. The browser is parking windows that it doesn't want to keep going, and I think it's ruining all of my chat plugins that keep you guys on screen. Usually this computer is not that... Okay, let's check. Let's all control delete. This computer is due for a big upgrade, I think. It has a relatively good motherboard, though. Whoa. 100% of the CPU. Wait a sec. What's going on here? Who was using it? That was like system processes. Sees. OBS and Google Chrome are just basically double teaming all of the resources on this computer. Yeah, they're responsible for that 100%. So OBS is grabbing a little memory, and Google Chrome is trying to grab everything else that's available and making more information, more resources available to other programs. So what it does is it parks these pages and makes them take up no memory. And so what it'll end up doing is considering that I haven't clicked on a web page in a while, which are the chat windows, because those kind of run on their own. It'll try restarting Chrome. I don't know how to do that cleanly. I have 2 different accounts open on Chrome right now, so yeah, if there's like a memory leak on any of them, let me see here. I could just right click on it and close that way. Okay, I'm gonna do it. Close all windows. That one goes away. And this one doesn't have a close all windows, just close the one window. And then I'm gonna cache the chat in OBS, and then I'm gonna open up Chrome again, choose this account, and then we'll Control-Shift-T it. Oh, it wanted to update and probably turn off ad block. I got my eye on you, Chrome. I'm watching you. Okay, there's all those windows back. Oh, I've got a couple more. There's that one. Cool. All right. All right, so everybody's open. I've got my creator dashboard is opening still. That'll allow me to catch up with you guys. Do chat windows really run in Chrome as opposed to CEF of the OBS? I don't know what any of that is. Yeah, I'm Control-Shift-T'ing it, yeah. Yeah, the CPU immediately goes right up back up to 100%. That's probably what's going to happen. Hold on, let's I need to get the chat windows open. Twitch TV a bother, and then we'll pop this one out. I really want to make that plugin where I have like a little screen and it'll go through the members of my Twitch chat and find out who is the member of my chat with the most followers and display their name on a little screen. It's completely toxic. I love how toxic it is. Let's see. Pop out chat is there. Got all those Twitch plugins running. Okay, so there's that one popped out. All right. That will put Twitch chat up here, hopefully, if somebody leaves any comment. And then I need to go to my VOD, the YouTube VOD. Bother VOD. Come on, come on. Open that up. And then we need to pop out this chat. We still haven't gotten the screen hooked up because there's a couple weird things that I need to figure out with the pinout. These Noritake e-tron screens are not I2C compatible. I2C would be so much easier. They're also 5 volts. So we need to make sure that we're hooking everything up correctly and not blowing up my Raspberry Pi. Then I'm using somebody else's tutorial, and it's in German, and it's got a ton of pop-ups that completely ruin the experience of reading this tutorial. Translate to English. Poorly. Most common for multi-line character display is HD 44-780, and because people aren't specifically making tutorials for the Noritake e-tron display, this is compatible with an HD 44870 LCD controller. I'm better at doing this stuff with microcontrollers, to be honest, but yeah, let's check. Didn't come up. Great. And I don't see it in this window either. Man, you know, like, okay, restarting Chrome did not help. It might help with the memory, but it didn't connect my plugin again. I'm gonna cache chat and see. Everything's just broken today. RS and E. You know, I'm just gonna hook it up. You actually don't have AdBlock working. uBlock Origin Extra stopped development in 2020. They may have stopped development, but you can still have it run. I thought it was doing something. Yeah, what's the worst that can happen? Well, the LCD display can set a pin to 5 volts. Not 5-volt tolerant. Just try normal uBlock Origin. It's not even AdBlock. Oh, it's just the extra. You know, at some point I'm gonna make this whole thing work on Firefox. It doesn't have backlighting because the characters themselves are lit. Oh, really? It's an add-on to the main. Oh, maybe that's why, yeah. Mozzarella Firefox is tastier. Yeah, so I'll just move this stuff over. I think what I'm going to do is research into whether or not I can get more RAM for this computer, just to make it limp a little bit further into the future, so we don't have all these windows parking all the time. It's probably going to be super expensive because I think this era of computer is in that that time when everything went cheap and now it goes really, really expensive. So it's probably going to be like, hey, you can buy more RAM, it'll just be $500. And so that's probably going to push me to look at Micro Center for like a MOBO combo deal that I could get in order to make the streaming computer more modern. And I'll figure out what the hit is there in terms of cost. At that point, I'm debating on whether or not I want to actually move this whole system over to Linux. That would be kind of interesting. 3v3 is something the engineers making didn't even consider. What? Oh, I don't know how old this thing is. It's probably 90s era. I don't think there's any date codes on this. But the ones that Noritaki's making nowadays are compatible with, you know, like 3-volt signals, and they speak I2C and all kinds of stuff like that. DDR4. How the fuck? Computer people are so obnoxious. Not you, but I mean computer people in general. Well, we're still up in the upper 80s of resource utilization. I'd love to see Linux at work. There's nothing I really can't do with Linux except run Fusion 360. Uh, 16 gigs was probably not a good call. I probably should have put 32 in this because this is more of a media computer. Yeah. Maybe it would be nice to have 2 computers. One could do the streaming and the other would do the working. And that way they would be totally isolated from one another. This thing has a 1080 FTW in it, which is enough graphics card for any of the stuff we're doing typically. It's possible, but bad to run Fusion 360 and Ubuntu Debian. I've done it, but ew. Yeah, but I mean, they've also got like the online editing stuff too. And I think I might have access to that as one of the content creators that they fund. What is that? Green light. Oh, Ideal is Idea with an L. And so Node-RED picked up on that and lit up the Idea light. The good Idea light. Yeah, I'm debating about it. I mean, I would much rather be in a Linux environment because then all that crap that Microsoft is doing in the background wouldn't be happening, and I'd have my resources would be mine. And then the microcontroller operating environments are pretty decent in Linux from what I hear. Sometimes it needs a very advanced setup and it didn't exceed. I just think it breaks now. And with updates, Fusion is dependent on .NET and a bunch of other things. There's other, I don't know, there were several suggestions. There's like, as with Linux, there's a way to get in it from the front and from the side, right? And the two seem very similar, but they're not compatible with one another. And so you gotta be really careful about where you're getting your information from. So somebody may have an idea of doing it one way, there's another way to do it. And so, yeah, in Fusion, the updates are mandatory. I don't know. I mean, like, is there any chance that they're probably not. They're actually ending the Windows 10 compatibility for Fusion 360 soon. So that's kind of what's pushing me towards Linux, because I really don't want to go to Windows 11 on this computer. I may have to if I'm going to continue to use Fusion 360. The mandatory Fusion updates and being forced to log in made me use Blender instead. You know, I've liked my time using Fusion. The reason that I use it is because I cut my teeth on AutoCAD. That's what we used when I was in college. We used AutoCAD, and so from there, I was like, okay, I want to build a circuit board now that's a thing. How do I do that? And so I looked around and I was like, well, SparkFun and all the makers are actually using what was it called again? They're using Eagle. They're using Eagle. And so AutoCAD said, hey, we want to make circuit boards. Look at this little company over here. And they said, here's $1 million. I don't know how much they bought it for, but they bought Fusion. And so having bought Fusion bought Eagle. There we go. Having bought Eagle, it's like, well, okay, so those are the two programs that I know how to operate and build stuff in. So I'm going to continue to use those. Really, I've never had it frustrate me that much. I have been frustrated with it, and it turns out there's a way to get around some of the selection stuff. But from my experience, their camera, like the way the cameras orbit stuff and the way all of that works has just been second nature to me. Then again, like, you know, I'll suffer through extremely janky things, and I don't get mad at stuff. I guess I do get mad at stuff, but I sort of give it a lot of leeway before I get mad. And maybe that's just from being around my mother on the computer, who externalizes every single frustration that she has with the computer. And so it ends up being an interactive experience whenever my boomer mother is on her computer. It's really, really irritating to be around. Why isn't this open? What's going on? Why is this like, what is this? What's going on? Why is, okay, that's not working. It's like, stop it, figure it out yourself. Okay, which one of these comes back from the LCD? Which one's the communication back from the LCD? That's what I need to know. I need to know which one, what the direction is of all of these, so I know if I need like one voltage divider, if I need multiple, right? 3.3 volt micro, 5 volt LCD images. What in the holy hell? This is always very annoying, and I should probably commit some kind of schematic to a folder so that I know how to do this, because the LCDs around here jump around projects enough that I find myself having to look up ancient texts in order to figure out how to plug these two things into one another. That one, I think, is specifically referencing a Noritake. Oh, a Nokia, never mind. I was close. It was close. It's not, that's not close at all. One's Scandinavian. DNDC reset SCE. Okay, so this is not what I'm looking for. Those 510 displays are pretty good. I know nothing about them. I should probably know more about that. The Nokia display. It would be pretty funny if we had a Nokia as a display for something. It's a really cheap dot matrix. I'm not about to commit to a dot matrix. Mega uno. Uh, microcontroller 5-volt LCD schematic. Done schematic. This looks like they're both the same voltage. You would think I would be able to find this more easily. Sorry about the struggle today. This wasn't supposed to be a struggle day. How to drive 5-volt LCD module, 3.3-volt DISPIC DCS. Actually, this might actually have what I'm looking for, even though it's for microchip. Dios mio. All right. There was a whole ass image that linked to this, but since all of my plugins blew up because Chrome is a piece of shit, I don't get to see the schematic. This is pretty much the answer to the question that we were asking, except I don't see any voltage dividers anywhere on this. There is a big resistor here, but I think that's part of the backlighting. We don't use backlighting. There is a backlight command. I think it's a specific command. It would be nice if I had jumpers on this thing so that I could turn it into I2C, but then I would need an entire level shifter for it to turn. Well, there's ways you can use just like a single transistor in order to turn 3 to 5 volts for like I2C. It's bi-directional way to switch it. First time using KiCad. Not what I'm looking for. Most of these are just hooking it straight up. I don't know if there's any communications back from the LCD. Interfacing STM32 blue pill with blah 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 LCD. I love how all of these show it when it's all like super duper easy. Nobody shows the annoying thing that we're dealing with. The Pi is only sending to the screen. The screen wants 5 volts, but 3.3 is enough. Does it only send? It doesn't get anything back. So that was my question earlier. If it is only this website. If it is only sending, then I can just hook it up. Yeah, the threshold for high is above 2 volts for this specific display. So we can just use this. Okay, that's what I was getting at. I was trying to find a source of that information. So if I hook up read-write, if I hook up RS and E, then it should be okay. I need a couple more wires to do that. How many more do I need to be hooking up though? And then when I hit run on this program, it'll just start speaking German. Maybe this is what's taking up all the memory. If it's RW, maybe it can be bidirectional. That's what I'm worried about. Yeah, that's what I'm looking at. Yeah, some people put a bunch of level shifters on there. That's a waste of level shifters. You can just use voltage dividers if you really need to. But I was looking for something that did what I'm basically about to do, which is just send it, just hook it all up. See, I could get one of these things and paste that to the back of the LCD and then solder a bunch of wires here that go to the parallel, not the parallel, but the 2 connectors. And then I would have power in 3 to 5 volts, ground, etc. I don't think this thing is going to boost to 5 volts though. I forget, but we used this in another system that uses a Raspberry Pi with a display. And I used it to good effect. You know, I hooked this thing up to the Noritake screen, and so I've got 5 volts going up to the tap handle with 4 pins, so it's a less of a massive wire. Yeah, I guess. I don't know. Or I could just let the Pi blow up. I've got a bunch of Raspberry Pis. That's a Pico Pi. That's not the right thing. Okay, let's just hook up the rest of the pins and just see if it blows up. I'm just gonna send it. Fuck it, I don't care anymore. If it blows up the Pi, it blows up the Pi. I've got more Pi. We can just bake another Pi. It's not that big of a deal. How many pins do I need? Who knows? Who knows? Who knows? Okay, so what is this guy hooking up to? E. GPIO 17. All right, so GPIO 17 hooks up to E. E is pin 6. It'll only ruin the pins it's touching. That's not as comforting as you think it is. 1, 2, 3, 4, 5. Pin 6. This one is E. Good. We'll keep the similarly colored wires near each other. That's going to not cause massive amounts of confusion. Wait, this is much shorter than... Hold on a minute. I want these to be similar lengths. It'd be nice if they were... Well... I wish I had that parallel, the IDC cable. Is this the length? No, these are like super long. Where did these come from? Weird. I'm gonna have all these different length wires connecting everything, huh? Put a real short one in there just to annoy me. Actually, I'm putting all these little shorties together over here. I don't think I could use them nearby. That would probably be the most convenient though. Is to use the little short ones. But I do have a couple of these sort of mid-lengths. So, all right, I'm gonna split these apart. Pin 6 to E, which is going to be GPIO 17. I'm just going to hook it up properly first, and I can make it pretty over the weekend. Because maybe I can buy some IDC cables. G17. That's E. Oh, 17 was our LED pin. Well, we're not using the LED pin now. I just want to get this thing running right now. So pin 5 is read write. RW. RW goes... clicked on the wrong thing. I keep bumping into the mouse. RW. Ground. Oh, because write mode and read mode. Okay, so that's why we're not going to blow up, because we're putting into write only mode, or read only mode rather. No, write only. So this goes to ground. Up. So if that pin slips, we could be in trouble. Register selection. RS. GPIO 4. Pin 4. So it goes 1, 2, 3, 4. So it's the back pin. The I2C would have been 4 wires. 4 wires. I got to go through all this to get this LCD running. God, the web page that I have open, it's just all ads. There's just moving ads everywhere, and it's just a huge mess. I am very tempted to go to Firefox. Ugh. Am I really going to go to Micro Center this weekend? No. But the memory getting crunched in this thing is getting very annoying, so I may pop my face into the computer and see if I can buy more RAM if it's not going to be prohibitively expensive. So that would be register selection, contrast, tension we're not doing. And I think that's everybody. So we now have this thing fully hooked up with 5 volts. It's only going to be writing to the display. I need to find a place where this thing looks okay, where it can sit. I definitely need to get that flat cable. How many pins is this? 14? You get a 14-pin flat cable, so this isn't so crazy. Or the I2C converter for this thing. Although if I do the I2C converter, that's two-way communication. I have to do a level shifter in the middle. But I should buy one of the... Wait, let me see if I have one of those boards. I think it would be over there. Hold on. I think I... Is that in... No, this is all e-watches. Here's another thing that I would love to hack and take over, but I don't have all the time in the world. This is like a biometric watch from cheapo supplier. Yeah, there's nothing in here. Okay, nothing in here. Take this over and make it like a little display on something. I think it only has a particular display to it. Where did that bin go? I had a bin that I had a bunch of LCD stuff in. There's like a little magnet closing bin, and I don't know where it went. It lived on top of this part of the shelf, and now it doesn't. So I have absolutely no idea what happened to it, but I think I had a spare one of those I2C conversion boards in it. I'll just have to buy more. I'll just have to buy them. Yeah. Yeah, I'm gonna buy even when I try to put a complete freeze on buying stuff, I'm caught in the fray, and I have to still continue to buy stuff. This actually LCD has been powered since I plugged in the power pin. Huh. This thing has been powered for some time. I don't know if it's actually active. Okay. Well, let's run the code. So all I need to do here is hit save on the Notepad++ file and then go into the console and run the Python. So Control S. That's going to do its thing. Double check with WinSCP. It's uploaded the file, 4 kilobytes. I go to the console, I hit up, and then enter. And then we can look and see if this thing displays any text. It does not. Nothing. Curse you! Raspberry Pi is still powered? Still powered. We didn't draw too much. We double checked all of our... Well, we didn't double check, but we checked all of our pins. Oh, wait a minute. Power's the yellow wire, yeah, and then this one's ground. So power and ground are both hooked up there. This one is 3 volts in ground. 3 volts is all the way out here. Nobody's connected to it. Ground is here. Ground is connected to there, which is connected to ground. And, oh, wait, what's going on there? Oh, bad connection. This is the annoying part about working with jumper wires. I almost saw something. So it doesn't appear as if it's tanking specifically for... Oh, that would turn read to write. That could have killed our Raspberry Pi. Pi seems okay. Let's Control C. Oops, I'm in the wrong window. Control C. And then I'll hit up. You smell something? Yeah, we got bad connections in some of these. All right, I'm going to hit enter to run this again. Okay, well, something. Oh, you know what? Hold on. Ootloo. I mean, you can see that the display looks kind of cool, right? That's the neat part. It is speaking in tongues, but it does work. Ugh. It works when everything is positioned just right. That's the only problem. This is sucks. I need to convert this to I2C, I think is the plan. Step up driver noise when it's unhappy. Oh, could you guys hear that? That's when I touch the ground on this, yeah. That's my thumb was over top of this, and that's probably making a ton of noise. Yeah, because these VFD displays use high voltage, and so it's got to step up to have enough current to run this thing. Oh, wait a minute, it kicked me out of the program. Oh, one thing is we didn't define the display. So defining the number of characters on the display might be the next thing. Yeah, you want to isolate them and stuff, but LCD width 20. Control S. Really? Did it call like doot 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 doot? All right, so that's up. Console. I can't hear it. I don't know what you guys were on about. But I think what I want to do is just get I2C stuff. There we go. It's Shinju Funkington or whatever. Oh, that's cute. It doesn't have those characters. Ist ein odd days ist ein. Why are you German? Yeah, so look at that, man. We got that working with the Raspberry Pi. I think this is gonna be. Du programmierst in Deutsch? No, I don't know Deutsch. I am unlike most of my American brethren. I am aware of other languages. I am not skilled with them, but I know some words in some languages, and I know how to say certain things and curses, you know, satana, all that stuff. But I don't know how to utilize those languages from nothing. So this is just a little LCD test program programmed in German, but it gave me enough information that I could run a little test program for an LCD display. And what I did is so we were using Google, and I set it so that, oh, did that freeze? What's going on there? I gave it enough information, we searched for stuff that had been published within the year. So somebody recently used a Raspberry Pi 3, no, Raspberry Pi Model B, which is a little obsolete. I was afraid that that would be a problem, but apparently this is okay. I'm trying to touch the ground when I touch this. Is that ruining your audio? Maybe I can do this, and I'm isolated. The pinout on this stuff is a little bit bad. But yeah, we got the Noritake e-tron display running. It runs just like an HD blah blah blah, you know, typical Dies ist ein kleiner Testboten. Yeah, so we got our test here, and it works. Pretty cool. Now, there are other functions in this display, like dimming and brightening these characters. The way that this thing is controlling it, you can see it's a little kind of glitchy on that. That's just how this thing does it. Oh, now it ended again. What a weird program. It seems to like randomly do certain tests and just kick me out of the program sometimes. Maybe it's because I moved. If I'm totally and utterly still, this might get through the whole test. This is a small test of an LCD. Why is it no longer doing all of the weird stuff? That's strange. There's like secret hidden functionality. Look at this, but it's not doing it. No, it's not doing it. Maybe all of that stuff was it actually getting the wrong signals or something. Well, if I lost a pin, it's because this is the jankiest setup in the world. These jumpers aren't that great. Let's try it again. functioning. Or is it because I need to like hit stuff? I don't know. I don't think that's doing anything. This is a small test. Yeah, you know, I think all of that weird stuff was this messing up somehow. But there was text that would walk across the screen and stuff. Was that not part of the test? Maybe that was a happy accident that happened to just look right. Weird. Very weird. So this is part of Burn the Subs. If I can get a light enough I2C function in Python, we can use this for test printouts, or in the end, it'll be something that will give me information about whether or not we're on the API, or you know what it's currently doing, so that it's not a total mystery. I piked up an IDC connector kit, and I use it all the time. Puked up it? Wait, what? It came with a crimp tool. See, I've never used the crimp tool with it. I've always just used like a flat vise to just squeeze it. I saw the stuff go across the screen because they looked a little like little ears. It was Japanese characters. There's a whole Japanese character set in here, which leads me to believe that there was some kind of an error, and it wasn't quite getting the data that it should have been getting. And so when it walked across, it looked like it was actually like animating something. Like, oh, that's cute. They actually made it animate something. When in reality, it was trying to pull the different letters in individually, and that just caused like a push command or something like that. LCD character displays have kind of a weird, I don't know, instruction set to them. All right, so we need a little bit of hardware to go along with this thing to make this a little bit easier to use. And then I guess the easiest way for me to do it is to do a transistor level shifter, so a two-way I2C transistor level shifter, which is an easy circuit to build. It looks like this. I2C bidirectional level shift. You just need a MOSFET, and you have your 5 volt on one side, your 3 volt on the other. And so is that bidirectional? That might not be bidirectional. That might be unidirectional level shifting. But then again, if we're only using I2C to communicate with the display, then we can just do that. I guess, is that bidirectional? That's a little bit more, yeah, bidirectional. This one is, how does bidirectional level shifter work? Oh, so maybe that is bidirectional. Wait, so if a signal comes in on the 5 volts, is that gonna, It's TX, oh, I see. TX to TX, that's not, I2C isn't TX and RX, it's SDA and SCL, serial data and serial clock. So it needs to be, well, actually depending, but I guess if we're only communicating out from the Raspberry Pi, we're not getting anything back from the LCD, we could do it unidirectional. Those little boards are like $7 for a 10-pack. It's more stuff I have to order. I have MOSFETs here. We have MOSFETs at home. Then that means that I don't need to get a flat cable. So nope, don't need the LCD. $6 for 3 and it gets here tomorrow. I feel like I have some of these, but we can rip out the backlight stuff from it too. Yeah, they're all the same. All right. You guys get to not look at this, and I'm just going to place that order. $6.99, and it gets here tomorrow. You know, it's death by 1,000 cuts with these things. Let's just order one more thing. $7. Fastest is tomorrow. The second is $2.99 to get it from tomorrow at 10 a.m. Or I could just get it tomorrow. Or I could wait until Monday, August 25th. Let's place that one. Oh, I could lower my carbon footprint. Why don't you tell that to like the corporations that do the... Now a bunch of robots in a Rube Goldberg machine of human suffering are going to spark to life and grab my shit and bring it over to a cage where somebody has to pee in a bottle in order to get through their workday. And I get to sit here and be annoyed that it's not here already. $7 and we have it tomorrow. I wish it was a little bit less of a Rube Goldberg machine of human suffering, and that the people who work there get paid, which they absolutely could. There's no excuse. But Amazon signs my paychecks, so... Or if they could build into the fact that I am one of their partnered streamer, so maybe I can get Prime for free and cause even more human suffering. That's really my goal as a content creator. I would like to maximize human suffering in the world, and I think the easiest way to do that is by being a member of Amazon Prime. Das ist kleiner Test, yeah. Yeah, okay, so success. We got the screen working. It speaks German. There's nothing wrong with that. It's 2025. It can speak whatever language it feels like. We can kind of interpret. We can read around and get, context cues for what it's going to say. So, das ist burns the subs. And that'll be totally fine, right? We will make it speak English in the future, and we will also make it speak I2C in the future. That's not a hard thing to do. We will hook it up to the same 5 volts. We can see that Das ist kleiner Test is not blowing up the Raspberry Pi in any way, shape, or form. So I think we're in good shape to get the LCD running. I would like to attach it to this whole setup. So we'll desolder the 16 pin. I'll put my own Schlamma-Jamma on there, our own little I2C converter. We'll have to pull some parts from that because we don't need that potentiometer on there for a backlight. Although I could put like a blue LED in this thing, or like a red LED, make it like red with, what would that even look like? I don't have a red LED available. I don't have RGBs ready to go. Oh, and then it died. I hate this setup. So we'll put like a JST connector on it or something, and that'll ensure that we actually have it hooked up properly. And so that can be our sort of like serial printout. We don't necessarily have to print out the console. How can we help with this human suffering? What if I order a bunch of same-day stuff from Amazon? I'm sure it's fine. Yeah, get your order in 7 hours for free. It's like, what's the catch? What's the catch? I don't trust this. Somebody, and as soon as you hit that order button in the background, they start like, slapping somebody around. Go faster. Go get their order. And you're like, I didn't ask for that. Wait. So anyway, that was a success. We can do it by means of parallel communication, but it's kind of messy. The alternative to that would have been to plug a flat cable into this, and then I could maybe break it out over here, and then we could hook it up that way. But I think overall, the display doesn't need to be serial fast. It can be I2C. It can be 4 wires, power, and then 2 communication lines are enough to get the LCD running properly and doing all of its job. And it might simplify our coding a little bit. Maybe I could find like a plugin. If I were doing this with a microcontroller, it would be as easy as finding some kind of a library that I saw would be, like the shining example of a good library, which means not going through Adafruit. Adafruit will most likely have a library, but Adafruit uses their libraries and information to, in some cases, to just barely get the thing functional so that they can take a picture and put it up on their store, right? That's totally fine. But I've seen a lot of people rely on these Adafruit libraries, and you're not necessarily capable of reaching every single operation of the hardware that you're using. And so I tend to look elsewhere for like a really good library, and there are some amazing microcontroller libraries for running LCD displays in general. But for this, like, we're not using an Arduino, so I've got to look for like either a Python library or a capability that Python already has to run something like this. We found in German that we could do the serial interface just natively. We didn't need to use any additional installs or plugins on it. I may need to do an additional installer plugin so that we can just have lcd.print and then have it print whatever characters we want it to. And I would like to access some of the extra features. I don't know if actually getting the commands that Noritake wants. I should probably contact Noritake and get their datasheet so we know that additional information. So all those things are things happening in the background. So I can't continue. I think I am done streaming for the day. We succeeded fairly quickly after some stumbling, but we were able to get the LCD to work. The whole serial versus parallel on LCD thing is just quite an annoyance. I'm gonna have a bunch of these I2C converters, and I don't know where. I feel like I probably have one in a bin somewhere, right? What the? Wait a minute. Hold on. Let's get back over here. Hold on a second. By all means, I probably should have one in here, stowed away. Close. Look for something with pins all on one side. There are some mighty powerful microcontrollers in this bin that I've never needed to use because they're too powerful. Too powerful for the kind of stuff I do. We even when we're like hacking something, I don't need to have a Teensy 4.0 doing that. There's a lot of pressure sensor stuff too. That's distance sensors and stuff. It's gonna be in a bin somewhere. I'm confident that I probably already have one of those things, but for $7, I guess I can't. I can't afford not to do it. Can't afford not to buy it. All right, so I guess we're just in waiting mode then. Yeah, maybe I could program my own. No, no. I'm waiting for parts on multiple projects now. This is my worst nightmare. That's a good looking toad of things. Very jealous. This has been accumulated over many, many years of streaming and stuff. This started out as a 301 breadboarding kit with sensors and stuff that Hackaday had suggested to get. So I got it, and it was like kind of amazing, all the different sensors. But then over time, I put them all into just this bin. But there's all kinds of weird stuff. Like we have a LIN bus adapter from when we did the steering wheel project. So looks like my bins, I got some FPGAs somewhere. There is a tiny FPGA in here. It seemed like it was going to be one of the most, oh wait, this isn't it. What is this? Oh, this is a USB-C power thing. You can modify this to request whatever power you want. This one is set for 15 volts for synthesizers. No, there's somewhere in here, there's a tiny FPGA, and it is it's like this size, but it has FPGA capabilities, so you can do some pretty amazing stuff with it. Like really, really amazing stuff with it. I haven't found a project to use it with. I was gonna maybe do some audio stuff with it, some low latency audio, I2S audio stuff, so that I could do all of the filters that I want on my mic just with my own thing. But we didn't get around to it. So someday I'll have to learn how to program an FPGA. I know Scanlime was doing some stuff with FPGAs. I should look into what she was doing with all that stuff. But yeah, it's an array of sensors and microcontrollers and just doodads. VHDL or Verilog. Yeah. VHDL and Verilog, I have not wrapped my brain around. I don't think it would be that difficult, but there are some FPGA elements in these Teensies. I would have loved to use one of these Teensies for the joystick project. I think that's eventually what I'd like to do if I could communicate via USB with one of the joysticks. Although just putting all the sensors into the Teensy and making it a pull-down menu joystick would be very easy to do too. We'll have to come back to the joystick project at some point. Scanlime is still active, but she disappeared. I have not caught up with Scanlime in 10,000 years. It's been too long. So yeah, I don't know. The last she was mentioned, I think we raided her channel like back in the day, but that was like pandemic times. So I don't know what oh, network error. Oh my God, I unplugged the Raspberry Pi. Yeah, so there's two streams that were a pretty comprehensive Raspberry Pi tutorial on how at least to just load code. I tried not to read or I tried not to come up with my own code very much because I'm so out of practice with Python. Python can be pretty easy, and I do like how it's a conversational flow when you start actually programming it. You start thinking in loops and stuff, and you can just bop, 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 write them down, and it works. I am that way with C++, whatever Arduino C is, I am that way with, because this is what I default to. But using other languages, like getting to know Python is pretty neat, because you can do some incredibly computery complicated stuff without having all kinds of like low-level function stuff going into it. And then you can also cast you can get like a lemon drop, and you can cast lemon drop as an int, and it just lets you do that, right? You can say, hey, whatever this fucking thing is, just make it into like a float. And it's like, Python's like, okay, yeah, sure, why not? Let's do this. So it can mess you up, but it can also be kind of beneficial. We'll work with Python more though, and we will get the LCD working in a way that I can use it to do like error prints and stuff. And then we need to move over to LEDs because I would like to get one of these big matrices of LEDs to also function with the Raspberry Pi along with everything else. And then from there, I would like to look into whether or not Project M can somehow get to the LCD or somehow get to the LED display. It's probably going to be a ton of resources in order to run like a full image of, animated image of what it wants to build, and then picking out individual LEDs from that and sending it to the screen. I don't know. It'll be interesting when we get to this. Hello and goodbye, Copper. I'm actually winding down. Here's the end card with all of my information on it. END. It's dynamite. I'm going to be on Discord. I'm not going to be on Blue Sky because it got hacked. I keep it in there just in case like it unhacks itself. And then I don't know what people are doing around Twitch. There wasn't too much activity when I left. Oh, everybody's online now. Whoa! All of my computer's resources are being used up. I really need to get a new one. I need to get a new motherboard. Yeah, Uo's lab is still going, and will probably be going for another 3 years, however many, 2.5 years. Snipe timer? Looks busy now on Twitch, so much to see, so little time. Yeah, you don't gotta watch everything that gets streamed, you know? But yeah, always my luck, just not other streams as well. Yeah, there's a little bit going on now. People have spooled up what they're doing, so you guys are on your own. You go find out whatever you want to do. In the meantime, I've got a lot of homework to do. I got to start thinking about upgrading this computer because we've run into memory issues just doing nothing. I feel like Linux would be the way to go, but there's a stumbling point where I won't be able to use Fusion 360 very reliably unless I use the online thing, because there's a way you can use Fusion online on a web browser. That might be the way to go with it, maybe. Tech Agents? I don't know their stream, but you guys go check out Tech Agents. I'm just gonna close the stream. I'm gonna close it down. Just close everything down. We don't have enough power to run everything, and my computer is running into. I need an end card that looks like a BSOD or it's now safe to shut down your PC. That RPi tutorial site was heavy without ad block. Do you think that's the one that killed the chat? I didn't think that would be enough to kill chat, but I guess it was running like 16 parallel videos while all kinds of other stuff was going on. Yeah. Constantly loading new videos in the bottom right. Yeah, that's okay. So that one was the culprit. That was a good tutorial though. Oh well. Anyway, we're gonna use I2C. We're gonna make it I2C, and then it'll work. I tried Fusion Web back many years ago. It's a little jank and limited. That's many years ago though. They update Fusion updates like every day. So it's got to be different now. I have not tried it yet though. All right, anyway, I'm going to leave you guys to your own. We'll be on Discord. You guys can check us out there. And yeah, have fun.